Hello, good afternoon or morning or whatever. I am back to work on my game engine. Um, and yeah, I'm streaming it too. So on my last stream, the day before yesterday, I had set up a basic 2D batch renderer using the ECS framework that I've developed. So that framework is to not simply make a renderer and make sprite components or whatever, but make a system for making systems. So you can kind of just come up with a new component type, call the scene manager's global methods and register code hooks, and so it'll start triggering and handling your code. And so I set up a simple batch renderer with it, and it's got some work to do. Obviously, it's very bare bones at the moment. Like, it doesn't even do calling, but I've got a couple of big things I want to take care of before I implement all of the nice renderer features. Things like material systems and stuff are going to come later. The first thing I really need to get done is to have text rendering working, because I want to be moving away from doing everything in code. So I don't want to be like designing levels by typing out a YAML file. Like this is what a scene file looks like right now. I want to be able to make an editor that will make it easy to author levels and to test out components and things, and to actually interact with the entity system and stuff like that. So text rendering is up on the docket. Before I can do that, though, I've got to get an additional feature working in GLSL. So presently, and I got all these warnings I'm going to be taking care of in a minute. We'll get started on that. But at the moment, I have a header system figured out where I can write a GLSL header that implements a feature like in a system, and then when you want to make shaders that are compatible with that system, you include that header and start using its macros. So in this case, the shader that we're running, it's pretty straightforward. The gist is that it just loads a texture and samples it after transforming it using the model view projection matrix. And so that code is pretty straightforward, but where it gets complicated is like you have to also support the batch system, meaning that you need to include the texture slots, because if you're batching together a whole bunch of sprites that use a bunch of different textures, then you've got to be able to see them all in one draw call. But then if you're wanting to use the shader for just single object rendering, then like that's different code that requires just doing, instead of doing a texture uniform block, you're doing just a regular sampler 2D uniform. And so in order to facilitate that, I've got a thing going where you can just include the header of, you can just include a header file, and it'll take care of all the boilerplate code and make writing your regular code like really straightforward. So in this case, all this boilerplate code that I just took out is going to be included using I think it's a batch textures.glsl. Yeah. But there's a specific thing that I can't include in it that we're going to deal with in a minute, and that is pragma option. So this is the header. It's located in my engine shaders folder, so I can access it in my GLSL code using angle brackets like this. There's a global header as well, enterprise.h, or enterprise.glsl, not h. Maybe I should use .h. I don't know. I'm on the fence about that. But this is enterprise.glsl, and it sets up the per camera transforms, the per draw transformed, meaning that like you set the camera once, and for every draw call, this is updated, but only for every scene angle that you're doing is this updated. And it comes with a basic EP position, which is used for everything. And so you just include it, and it sets up a lot of the boilerplate stuff for you. But this kind of shows you the power of working this way. So for the 2D renderer, I've got an include batch textures.glsl. And that gives us access to 3 macros. So we got btex, standing for batch texture, btex sampler 2D. This is how you declare a sampler 2D. So I make a texture sampler called text. And then inside the main function of the vertex array, you call btex pass to pass this to the fragment shader. And then the fragment shader, you sample the texture using btex texture instead of regular texture. So it's like, this is the way it normally looks. This is the way that the macro does. And so the point of doing all of this is to make it so that if this is used in a system that batches textures together, it will automatically include the uniform block. So if def batch textures. So this is defined when you're using one of the systems that batches textures together. It includes the sampler 2D array. That's just a block of sampler 2Ds that it can slot textures in when batching stuff together. btex sampler 2D, where you would declare your sampler, it automatically makes a input and an output for the integer, the vertex attribute that actually tells you which texture to sample this vertex from, and then that's passed through using pass. And then on the other side, in the fragment shader, you got the sampler 2D, which, or sorry, not sampler 2D, the down here texture, btex texture, which will, instead of sampling directly from the texture that you named, it samples from the sampler 2D using the passed through thing. And then on the flip side, when you're not using batch textures, it just does a uniform. It does nothing for the btex pass. It's just pre-processed out. And btex texture will instead just be a regular texture, so it'll work correctly in either system. And that makes and this is the style in which I want to write systems that work with shader code. There's just one little detail left, and that's this guy, pragma option. Right now, the way that I have include files working, pragma option does not work unless it's in the main file, because literally all it does is it copies and pastes the code from the header file into the shader code, which works great enough. But I really don't want to have to do that, where I have the option statement before the include that needs it. I want to put that inside of the header itself. So first, let me make sure that I didn't break anything by moving all this stuff back around. Batch textures dot GLSL. Yeah, and yes, I believe that's correct. Let's make sure that it runs. Yeah, it appears to. So this shader that's loading is this one we were just looking at. Simple as dirt, but it automatically will batch together when using the 2D renderer system or whatever systems may want to batch textures. Now, the first thing I'm going to take a look at, though, is that there's this unexpected warning popping up. And so I'm going to take care of this bug first. There's a call in my graphics system called enable shader option, and that's how you activate and use other shader variants. So when you do pragma option whatever, each keyword that you stick in here is a shader option, And so if when you go to compile the shader, my preprocessor will take this statement and insert pound define and then whatever keyword, and slot in whichever keyword and do that for each variant. So in the case, special case of underscore, the line is left blank, but in the case of batch textures, it would literally do this. And then code that, like if you go into the header, the code that has, if def batch textures, that code gets triggered. But for some reason, I get this warning that shader option already enabled option batch textures, which indicates that I've called it twice, and I'm pretty sure I haven't. So let's get to work on that. Enable shader option. First thing I'll do is I'll find all references to this enable shader option, make sure that it's not being used in a place that I forgot about. Okay. What? This is literally just the declaration and the definition. I know I'm using it somewhere else. Is my scope wrong? Find all references. Searching entire solution. What? Project, then definition. No grouping. What? Okay, whatever. It seems to think that that I don't have it used anywhere, but it's obviously being used. So I'll just do this myself. Thanks, Visual Studio. So we'll look for enable shader option. I'll do it with the colon in front to find when it's in use. Okay, so this one was commented out from an earlier test. Okay, so we've got enable shader option within the renderer, which is what I expected. And this other one that's commented out from scene draw. And this is the one back in the scene draw again, the renderer. So that's literally it. All right, so I guess this is the one. This is where we're having the problem. Enable shader option will it takes an optional second parameter. If you enable an option and set the second parameter to true, it will bind the correct variant for the currently bound shader. So that way, if you bind a shader, like prior to doing a draw call, you can bind a specific shader that you want the scene to be drawn with. Like you can do like a shadow mapping shader, for example. And then when it goes into the renderer, it will say enable shader option upon the shader that you bound. So it doesn't actually have to know what shader you've loaded. And for some reason, I'm getting duplicates when I do this. So let me just hit the debugger and start stepping through it. All right, here we go. So just gut check. Yeah, there's nothing in the console yet. Let's step in and step over, and this is the hashing function, hashing the batch textures. In distribution builds, that is done at compile time, but in debug it's done live. All right, so starting out, we got selected shader options. This is an STD set of the active names of options. It doesn't look like it's got anything in it, so that's good. So it's not in there, so the warning doesn't need to be triggered. Then if update shader, which is true in this case, then we will call bind shader again on the last selected shader name, which is test renderer 2D. So that's looking good. Let's hop into bind shader. Selected shader name equals program. Yeah. There's a little bit of redundancy going on here because we already because we got the selected shader name from this variable and then we're setting it again, but I'm okay with that. A little redundancy for the flexibility that the API offers. We check is shader viable. Probably should have stepped through that, but the gist is that we just go into the actual OpenGL shader programs, and we check whether first we check whether a shader by this name has been compiled, whether it's in the list, and if it has, then we check whether there is a variant option compiled that matches the active options. So selected shader options, in this case is 1, with this hash, which evaluates to batched textures. So that means that yes, we do have a batched texture version of this. Though now that I'm looking at it, is this? Hang on a second. Let me go back to OGL shaders. 172. Okay, no, that's right. Yeah, so we've got both the shader with and without that define. So both variants compiled successfully. So coming back to define shader call, we've confirmed that it's viable. Active shader name, we're setting it to program. Active shader name means the shader that's actually in use. So if for some reason you can't find it, there's a fallback system that will try and use. If you set a fallback shader, you can tell the engine to use a specific shader if the shader that you're trying to use doesn't support the options that you have. So that would be useful in situations like if you have a skeletal mesh system and you wanted to make a material that can be applied to the mesh, but you forget to include the skeletal mesh stuff, the skeletal mesh GLSL header, and so your material doesn't support skeletal meshes. Instead of just failing to animate, it'll use a fallback texture that supports the system. Or display in magenta, which is the fallback. But okay, active shader name is now set to fallback shader. Wait, no, we're up here, not down there. So we're setting it to what it already was, but it's needed. Active shader options currently is size 0, so we don't have an option right now, which is right because we are currently changing the option. Selected shader options correctly contains the batch textures tag. If OGL active program is not equal to shader programs at active shader name, active shader options, this is the OpenGL implementation's handle to the shader program that's compiled. It's just checking to see whether or not whether or not we actually bound it. And in this case, we've got OGL active program 4 bound, which is the version of this shader that it does not have a problem option defined. So that's this guy, number 4. Number 5 is the next one, which associates with the batch textures key. Good. That's good. It's not equal, so we set it equal. Set the active program. We set the active shader name and shader options. And we call GL use program on it. So now active program is 5, active shader name is test renderer 2D, and active shader options are, okay, so that looks correct. So far so good. When we continue, it steps out. So at this point, we don't have any warning. Okay, so that code seems to check out. So the next thing we do is we go through and we bind the textures that we'll need. And in this simple example, we've got 3 textures to bind. Bind texture is a little smarter than that. It actually doesn't always bind the texture. It will only bind if it's not still bound from the last frame or from the last draw. Basically, it'll just bind in a circular buffer fashion, and then if the shader is already, or the texture is already bound in one of the OpenGL texture slots, because you can have up to 32 textures on most graphics cards. If it's already still bound into one of those slots, then it just returns that pointer or that handle to the caller, so we are not wasting time rebinding textures. So we're going through that. I don't think there's anything in here that might be a problem, but that's why we're stepping through this. And this is just setting up we're making GL texture whatever the active texture. In this case, we're dealing with a sampler 2D, so we are binding to this, using the GL texture 2D tag, which is good. We've now got current slot of texture, texture and slot. None of this has to do with the shader that we're using, or the shader options. This might though. What do we got? We got sampler uniform types. We are accessing active shader name, active shader options, .count. I'm wondering right now whether I care that we're accessing active shader name, active shader options. In a lot of the code where I use maps, I will wrap these in additional conditional checks so that I'm not accidentally inserting keys I don't need. So I would do, for example, in this case, I might do if sampler uniform types dot count, and then check to see whether this key exists before I actually go on with the logic. I think this is a case where I don't actually care whether the key has been created. I just don't quite remember. So there's a hash name, the hash name of the program, the returns a map that takes a set of hash names, which is the options, the pragma options, which turns a map that maps the uniform's hash name with the GL int representing its type. Which, I think should be fine. The only reason why this might be a problem would be if it initialized to 0 and I needed it to be something else. Yeah, I think that's fine, because ultimately we'll be checking this for each. Yeah, so that's good code. That's fine. We do an error check for sampler uniform types. This is the .count, and this is the actual access. And we're checking whether the sampler that we need, the sampler, yeah, okay. We're checking whether the texture actually is a good match for the sampler type. So you're not like trying to do a 3D texture to a sampler 2D or something like that. If index, because we're looping through, the texture slots, I think. For I, this is last bound texture slot. Yeah, so this is going through the texture slots until we find assign if index is less than sampler locations, sampler uniform locations. Dot size. Right, because index oh, right. In this case, index is the parameter passed, so we would be providing a index into the array of textures in the case that the uniform buffer is an array, which in the case of the batchable shader is it's a sampler 2D array. Cool. Yeah. And while current sampler assignment, while index is greater than or equal to current sampler assignment, right, it's just making sure that current sampler assignment has the element to access if it didn't before. Setting to -1 to indicate a unassigned texture slot. If current sampler assignment, blah, 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 current slot texture, current sampler assignment, yeah, this all seems, above board good, because the, all of that stuff would not have to do with which shader you're using. Texture slots are universal. Okay, so I guess that worked out. I'm back in the scene draw now. So I guess there's not a problem with that. Did I just skip over set model matrix? Set uniform buffer data. Or that should be fine. All right, so now we're down to the actual texture stuff. We're on the next loop of the huh. And I didn't get any warning so far. No, I guess not. So I guess if we continue, it'll just take us right to the next enable shader option. Oh, that's the problem. Okay, yeah. That's silly of me. I thought that I was going to put this, the enable option as close to set vertex as I could, but I needed it to be above bind texture, because texture binds to a sampler 2D uniform within the shader, so that's shader specific. But I accidentally put it within this outer for loop. What? I didn't stop recompiling. I didn't choose to recompile. Whatever. I think I just double clicked on something and tried to recompile. But this actually needs to be out here, because otherwise I'm doing the enable once per every sprite, which it'll still work, but it's wasted time, and that's why I have the warning. All right, so enable and then disable. We got draw triangles here, so we got the set vertex data, which is handle. It just pushes all the new vertex data that we calculated on the CPU here. So we do all the transforms in aggregate using GLM's SIMD to speed that up. And yeah, okay, so that should be better, and we should be able to get to the titular topic of actually getting the GLSL headers to work fine. Cool. No more warnings. We got sprites rendering, and going back to the shader code. This is the shader that we're running. We're very simple on the code, even though this is a shader that can do a batch variant or a non-batch variant, which is great. Minimal setup, and that's the whole reason why I went through all the trouble of doing pragma option and include for GLSL, because those are not language features. So now the remaining thing is to put this guy inside of this guy. Oops, I accidentally copied something else instead of pasting the thing I wanted. All right, so the idea is that when you go to use batchable textures, you don't even have to do the pragma option. They just include batch textures. You just use the macros, and then it'll automatically work with systems that batch textures. Yeah. I'm not sure actually that now that I'm thinking about it, I'm not sure that batch textures is the correct terminology. Because we're not batching textures, we're batching geometry, but it's a system of making sure that all the textures are available for batch geometry. I don't know. I'll think about the wording of it and maybe retitle it before I commit it to the repo. But the idea is that this should work in here, and I know in advance that it doesn't, because I didn't add that feature. And so we'll see that when I set it up, we've got 3 magenta squares instead of having the actual sprites. If we take a look at the warning, that keeps popping up every frame. It says bind shader, unable to bind shader program, and no fallback shader has been set. So it's not able to bind the shader program because it didn't compile correctly. So it doesn't, the variant, for batched underscore textures doesn't exist because the pragma option statement was not executed. And so in data GLSL dump, yeah, so we've only got this one variant, which is I've presently got the engine dumping my pre-processed GLSL code to file. So we've got this variant, test renderer 2D, where we don't use batch textures. So this is the pragma option line. It's just left alone, and GLSL already ignores pragmas that it doesn't recognize. So this is just skipped, but there should be another version that has the defined batched textures. But that's not compiling because we got to get the thing working. So we'll know that it's working when I can just press F5 and I'll see the textures pop in again. The shaders are written exactly how I want them to be. So let's do that. I think this will be the last GLSL parser thing I need to do for a long time, I think. Hopefully. And then after this, it would be onto the text renderer, get some glyphs rendering. All right, so here we are in compile shader source. So presently, here's how I handle the include. So when I encounter the include line when I'm parsing the GLSL code, I will identify whatever is in between quotes or angle brackets. So quotes put this in the regular virtual file system. So you can have a shader file or shader header that's part of your game content files. or it uses the bracket, in which case it reads from the engine library stuff. That's the stuff in the engine cheaters folder, which will also be distributed with whatever game or executable you make. After it has identified the path, here we go. So we hash the name of the path for later use. We check whether we have already included this file where we got included source strings.count. Include source strings is a map mapping the hash name of the file. So the hash name in this case is the hashed path string, so the path to the include file. And it associates it with the std string, the C++ string, containing the actual source. And so here we're just checking to see whether it's included. If it's not included, then we load the file. And that's what all of this section is for. And after loading the file, it will be available for use in the following section. So our work is going to be done down here, assuming that the file, or no, I'm wrong. It would actually be done when we go to load the file. So the gist is that when you go to insert into the file, what actually happens is that this whole time, while we are parsing the entire GLSL file, we are assembling an ordered list of pointers and lengths. So the pointer is a char pointer. It points to the first character in a string, in a C style string, no matter where that's stored in your memory. And then we have a corresponding length to it. So there are two arrays of C strings, basically. It's just that they're not arranged in like contiguous memory. You got the list of the pointers and you get the list of the lengths. And GLSL takes that, or sorry, OpenGL takes that directly. So if we go to docs.gl, very good OpenGL OpenGL documentation site. So GL shader source, which is the method that we use to actually pass the graphics driver the GLSL code. It takes an array of const car pointers, or an array of GL car pointers, I guess, and then an array of lengths. So we just assemble that list. We don't have to do any allocations of the strings on our end. We just say, all right, so for this first section, use the stuff from the source file. For this next section, use this define statement that we assembled, in a buffer somewhere. And then for the next line, use the source for the include file. That's all being done right in here. We need to get in the middle of that process, and in addition to inserting the include file, we also have to insert its pragma statements, which is why this is going to be probably a pretty long project, but totally worth it. So the first thing is that we need to get the list of we need to get a list of pointers and lengths going for each include file. And so when we go to insert the include file in here, we will insert exactly what we need. But we have to go one step further, and we also have to tell the overall GLSL parser that that there's a new variant to deal with, and that's done by pushing. I have a separate list of indices into the shader parser, the parsed shader code list. So a separate list of indices going into the pointers that I would feed GLSL shaders or GL shader source, and then from there we can retroactively go and change the pointer to be the pointer to the other option name, or a pointer to just a space character to get rid of the pragma statement if we want. So I have to populate this list and I have to populate the source list with multiple pointers. So step one is to parse through the include file and get out its juicy pointer list. That is, I think I scrolled too far up. That's down here, yeah. So that's going to be in this block. So this is where we do the file loading. If the file exists, then we call file load file, give it the path. We give it the we give it the address of the source string in the include path table, or the include source strings table that we want to store it in, and then load text file just fills up that string with the text that we need. So this part doesn't change because we're still going to just load that up into contiguous memory. But now, in addition to setting that up, we need to parse through it. So what's this next bit do? Graphics compile shader source cannot load, blah, 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 blah. Oh, this is the stuff that happens if it fails to load. If it successfully loads, then we need to add an else down here. Or maybe more correctly, we should be doing if load file equals a success, then we do parsing. And then we do else when we do the other. You always want to do the most common code path first, or do it so that the check is you're more likely to have a successful check on a given execution of a code branch. We're going to be mostly loading up files successfully, so we check that, not if it isn't a success, do the bad thing, and then do the good thing. So at this point, we've got the source. I need a place to be putting the, and there's a lot of code. I need a place to be storing the pointers and lengths. So this is these are the actual buffers that we're storing for GL shader source. These are the pragma option ones. Where did I put the? All right, these are actually gonna, unlike the shader source that we're passing to OpenGL, I am actually going to be holding on to the pointers and lengths for the strings within the include files, because those I want them to persist between shader compilations, which at the moment, you know, that does mean that if I go to reload a shader file at runtime, that it wouldn't reload the header, but I'm okay with that, I think. Or maybe I would have to, maybe I could just like flush it and then reload them all again. Yeah, I think that would work. I'll deal with that when I deal with reloading shaders, which won't be too far in the future, but that's actually relatively easy to implement. Uniform buffer sizes. So where did I put the include source? Up here, okay. I'm not sure if that's the place I want to keep it in this list, but whatever. I'll deal with tidying this up before I go to post this on GitHub. So what we need is basically a vector of GL car pointer and a vector of GL int for each one of these. So I do need this to be a map. We'll take the hash name of the include path as the key, but then the rest is going to need to be std vector of GL car pointers. I'm using the OpenGL type because at the moment this is a GL specific file. In the future, I might branch this off and do its own thing, and then do a version of the shader compilation process for Metal or for DirectX. But whenever I'm providing things for the OpenGL API, I tend to use the exact type def that is used. Glad provides these. Glad the the OpenGL binding library that I'm using, or loader library. So we got a vector of character pointers. This will be include. I guess they would be source. I've been calling them source strings in the other, I think. Yeah, strings and lengths. That's going to be a little hard to differentiate from what I already call include source strings. I guess I could do include source buffers. That makes sense to me. And then I can call this one include source strings and make them the, yeah, I think that makes sense. Static std map. We'll do hash name vector, and then this time it's glint, which is, interestingly, it does not take size t. You would have thought that, because size t is like the C way of doing the length of a string. It's unsigned and it's the biggest size possible. So it can reference a lot of sizes. But in this case, it's literally just a signed integer, so we use it. And then this is going to be lengths, like that. And now we've got to fill these up. So back in the shader section. So now we've got to handle these. This is going to be a significant amount of code. And this is already, like, the majority of this file is the compilation code. It's like, I don't know, like, it's well over 1,000 lines, just this one parser. From line 49 to line 49 to that's load shader file. Oh, no, it's not. It's compulsion. Yeah, 49 to 1881. So almost 2,000 lines of code, 1,800 lines of code. So I think I kind of want to branch this off into its own method, make it a little bit easier to follow. But, if I'm going to do that, I might as well do this whole thing. Do I have to? I can do a separate load method for loading the include file. Because if we take a look at the section that we're working in, all of this code could be encapsulated separately, because the only thing that we care about is the include source buffers, the include source strings and lengths, and that's globally accessible. That's a static global variable. wouldn't have access to the shader name though. Yeah, so I guess I'll leave the file opening stuff here in the parser, just so that the warnings that we check for opening the file can include the name of the shader and the line number that we're in, without having to like pass these into the helper function as variables. But what I will do in this case is I will make a method it's called load include, no, let's say parse include file, I guess. And I don't even need to pass it anything because I do need to pass it the hash name for the include path, so that way I can look up the correct elements in the table. But basically we would say parse include file, pass it the include path hash, and then all this does is it will go through the already loaded source buffer and generate the pointers and the length calculations. So let's do that. I'll throw an implementation directly above this method. Okay, here we go. So this would be the way to do it. Be a void. We'll take a hash name, include hashed include path, or include path HN. No, hashed include path. It's a good name for it. And then in here we will do the dirty work. So for starters, we just need to read the thing line by line. So I guess we'll need a string view to read line by line. Parsing is so much fun. And by that I mean not fun at all. It's great to have a working parser and compiler. It's hard work to make one. So the way that I was doing it in the main parser is I would do a for loop, parse the line start, and then I would plus equal line dot length plus 1, and line would be the string view that we use to store the next line, or to encapsulate the next line without having to reallocate anything. And then I would get the next line within the for loop down here. So I think this stuff is what I'll take. I don't need all of it, I just need some of it. But we do need the line, we do need the line number, do we need the line number? I mean, I guess we could use it. I'll comment it out, so if I decide I need a line number, I can just come back and comment it back in. We don't need parse state because that was used to track which mode of searching we're taking in the main file, and we only have one mode here. We're only looking for one thing. In this case, source is going to be include source buffers at hashed include path. Parse to line start is important because when we are getting the locations inside of the source that we need to insert the pragma option text into, we are doing that by calculating how many characters into the buffer to read, because it's not actually stored line by line, it's stored as just a straight array of characters, the whole file. Yeah, then we got line equals string view of, instead of source.data, we would use this .data, plus parse line start, which is 0 from the get-go, but it'll get bigger as the lines go on. Line equal, yeah. And then for the length of it, we do source find first of either a new line or a null termination character. And cars to line start. Yeah. Okay. So cool. We got a for loop parsing through the whole file, the whole include file. Oh, I need to replace that. Source buffers. Here. We're parsing through the whole include file, and we have a line each time. Okay, cool. So the first thing that we're doing is we're checking for pound pragma. So we'll do if let's get a cursor going actually. So size t pause equals 0. So this will be the point in the line that we care about. We'll actually start by searching for find first not of the first thing that's not white space. So that'll be space character, obviously, a tab. In some cases, a carriage return if for some reason it didn't get stripped. It really should be at this point, but I include it because it's considered white space by the C++ standard. Or maybe do it. Now that I'm thinking about it, I think I might have come to the conclusion that I don't want to do that at some point, but apparently I still check for it because it's all over my GLSL parser below. Yeah, I'll do that. I'll do the thing I've been doing this whole time. Later, if I decide I want to get rid of it, like maybe if like the parser is running too slow for some reason, I'll get rid of that check. But for now, I'm not gonna. And then we need to do it from the start of the line, I guess. So in this case, it would just be 0. We're literally at the start of the line already. We'll do if pause is not equal to std string view and pause. So if the line is not all white space, then we'll do something. If it is all white space, then we don't care anyway. We're just gonna let it loop to the next line. Actually, there's another problem I need to worry about, which is multi-line comments. So actually, I do need to parse. The problem that I'm thinking of is something that I actually have to deal with in the regular parser, which is that if you have a uniform or a header file and you do something like this at the end of a line, then the next line is invalid and you shouldn't parse it. So you actually have to watch for those. And because this is not just a tool that I'm going to use, it's actually going to be for developer shader code as well. I do need to fully support comments and multi-line comments and not like put a restriction on like, well, you're not allowed to comment after, a certain line or something like that. Yeah, so I do need to parse for the end. If it's all white space, then we can that thing where we just let it loop through, that's still valid. But I'm just realizing right now that I've got to keep my eye out for it. So first thing to do is I go if line at pause equals a pound, then we will check for pragma. Else if line at pause, well, I suppose we don't do another check quite yet. We're checking for pragma first. If it's not pragma, then we need to look for look for any comments if they exist. So I'll deal with that in just a minute. Actually, I should probably just do I think it's like line dot compare, and then I can do, and yeah, I can do an offset into the view and a size, and then a string to compare against. So in this case, it would be pause as my offset, because it's the position of the first non-white space character. And then the size would be pound, PRAGMA, 7 characters. Actually, I'll do 8 characters and have a space at the end. And then I'll do the string here, pragma, like that. And then equals 0, meaning that they are equal. This check actually just goes ahead and straight checks for pragma, and I think it like aborts if it doesn't find a character from the left. But yeah. Oh, hello everybody! I got raided. It's my first raid. Hi Narzal93 and the other people. How's it going? I didn't think that people rated channels like this one. Just doing some live coding. So if it's not pragma, then we need to worry about comments. So what I'm doing right now, for folks who are just getting in my game engine, I have extended GLSL to do include files, and the Start Today show is pragma option, which allows you to do variants, and I'm working on that parser. We were doing a game dev session in Unity, and it's nearly 0 a.m. now, so I wanted to raid someone. Nice! Yeah, that sounds like fun. I've worked in Unity a fair bit, but I did not know it is possible to require mobile phone number verification for the chat. What? Does it? Does it? I mean, I know it's my channel, and I probably should know the answer to that, but I basically just had a friend of mine help me set it up, and I didn't bother learning how to use it. Interesting. So it required you to enter your phone number to verify. I'm not sure if that's a me thing or not. Or I suppose if it was a Twitch thing, then you wouldn't have been able to chat in the other chat. So interesting. Yeah, I wonder if I should turn that off. But thanks for going through that hoop and chatting with me. Yeah, I do enjoy working in Unity. I just my interest is in kind of the core tech, and I'm learning an awful lot about game engines by building mine from scratch. Yeah, for the moment, I'm working on getting a feature working that it's kind of a nice to have, but basically, so right now I've got purple squares showing up because the shader didn't load correctly, and what I want to do is be able to, so this is the shader. In the shader, I want to be able to just say include whatever, and then have the include file automatically handle creating the variants that you need. So if I, as it is, if I have to stick pragma option in front of wherever I want to have the option for it to work correctly. And so now it loads correctly, because now there's an option that does bashable textures. But might want to turn that off because that scares some viewers. Yeah, I should. I just don't get a lot of traffic here. I'm not advertising this place as like a show or something like that. I just kind of like to work live. But yeah, thanks for the follow. Anyway, so let me get that back to where it was, and save it, and undo the comment and save that. So I'll know that it's working when I start seeing the sprites again. Yeah, yeah, working on a game engine, it is really interesting, and it's really gratifying when you have something working that you've been working on. But it's also just a whole lot of work, a whole lot of learning how to do things. And I'm not like a professional developer either, so I've learned an awful lot about C++ and how to do multi-platform stuff doing this. Anyway, back to the parser. So at this point, we've checked for pragma. If it is pragma, then we need to check for. Actually, you know what? I was thinking that I could just insert pragma option into here, but the problem is that there might be a variable amount of white space, and to be even more technical, it might not even be a space; it might be a tab character. So yeah, I'm actually going to need to do a white space check. So 1, 2, 3, 4, 5, 6, 7. Yeah. So we've checked for pragma. Now we need to find the next non-white space character. So pos equals line.find first not of space tab or carriage return, and then we'll do from pos +1. No, that's not right. Pos plus, yeah, actually +7. Because right now pos is pointing at the pound sign. Okay, and now we've got the first non-white space character. If I'm being tired. If pos is not equal to has to be string view. Technically, string and string views and pos are the same, but I don't know why I feel like when I'm working with string view, I want to be more correct and actually use its stuff. There we go. Pos 7. Cool. So if it's not npos, or if it is npos, meaning that there's nothing else besides white space following pound pragma, then I'm just going to let it skip and then not consider the rest of the line, because the GLSL compiler will automatically alert the dev to the fact that they've got a pragma that does nothing. But if it's not in pos, then we need to confirm if line.compare from pos, we're looking for the word option now, so OPTION 6. Option equals 0. Then at this point, we've got to handle the keywords. So I'll need to rip that code from the main GLSL parser. Pragma. So this is where we look for pragma option here. And in this case, what we do is we push back into option string name indices, which I'm trying to remember exactly what it does. There's so many moving pieces in a parser. Yeah, so in this case, we were tracking the option string name. String indices. All right, so this is the index into the buffer, or the buffer array, indicating a spot where you can insert an option string. So in our case, we have a global version of these up above. We're going to need a version of this for the include file. So let's do that. So we've got pragma option, string positions. So these are going to be for includes now. So let's do a control F. Pragma option, and I'll do just a quick replace within the selection to pragma. We'll do include include pragma opt. Give these slightly more unique names. So now we got the include pragma option string positions and links. So these are the C style pointers and links that we need for passing into GL shader source at the end of this. For each variant, have to pass to GL shader source. Then we've got the pragma opt string name indices, which is the index into these buffers in which you could insert these values, sort of. So there's going to be some spots blank spots in these buffers in which we can place the pointer and the I'm just realizing right now that I don't have a spot to store the pointer, but the pointer and the length. This is actually size T because it's an index into yet another buffer that I don't have yet, which is the pragma option buffer. So I need to have one for each. For each include file. So when we encounter a pragma option line, I actually need to make a buffer containing all of the options. Not unlike this, where there's just a string containing all the characters needed to substitute a option. Whereas they would be like the option and then a new line character maybe, or just the option by itself. And then when we go to construct the variant at the very bottom of the down, in line 1800 and whatever, at the very bottom when we actually go to stitch together all of the different variants, that's where we would use that index to get the pointer out of this buffer. And yeah, oh man, I'm having a really hard time just keeping it all straight in my head. I'll keep that note there, ordered by pragma line number, then options 1 to R, right? So I'm going to be using those. And heading back down to where we did this in the main GLSL file. I'm going to need to copy out some code. Case 3, I believe. Shader section parsing. No, case 4. Right, so 1 is looking for the shader name, 0 is looking for the EP shader line, 2 is looking for a pragma option, and then we move to mode 3 when we're looking for the options, I guess. All right. I feel that problem. Also, I'm getting sidetracked really, really easily when I see something that still needs to be implemented and fixed. 5 hours later, I'm at the point, what did I want to do again? yeah, that's, I totally feel you. It takes great effort and planning to get to the finish line sometimes. But yeah, here we go. So we got pragma option confirmed. So the first thing we do is we push back a vector on the pragma option string name indices stack. So this is ordered by pragma line number and then options. Okay, right. So I need the equivalent of that above. Then in this case, we just move the cursor past option, which, yeah. And then is pragma option. That's unrelated to what I need. That's just a way for us to track whether we're dealing with pragma option whether we're on a pragma option line after we get past this because of the way that the overall parser works. So in this case, I just need this line. Get back to the top, scroll down just a little bit, and oops. Except for instead of pragma option string name indices, it is now called include pragma option string name indices. Getting really lengthy, but I've got all these different buffers that I kind of need them to have names that actually describe what they do and not like try and abbreviate this in some crazy fashion. Include pragma option string name indices. So this just makes sure that we have a buffer to push into, because this is a vector of a vector, if I'm remembering correctly. Yeah, vector of a vector of size t. So it's like a multi-dimensional array, but it's dynamic. Each row, so each of the first dimension, corresponds with a pragma line number, and then we push back into the last one of these, push back into the back, the index into the buffer into this guy, to get its pointer to pass to GL shader source. All right. Yeah, thankfully it's going to be pretty smooth sailing after this. It's just going to be doing graphics work, hopefully. Parsing stuff is, boy oh boy. Could have just used freaking GLSL and DirectX and have all these features already built in. Well, the pragma option stuff wouldn't be in there, but include files would be. Where am I? Yeah, so we've pushed back the vector. Oh yeah, I need to see what we do in case 3, I think. Down here. Shader section parsing. That's not right, actually. We're still in case 2. So we've got pragma option confirmed. We move the cursor past option and we break, which breaks us out of this while loop. So down here is where we're doing the options. We do another while loop while cursor is not equal to the end of the line. Look for options named if not pragma option cursor already equals end pause. Okay, cool. Thankfully, past Michael has already commented stuff in here to make it easier to follow the logic. So at this point, we have confirmed that pragma option is the term that we've got, and then we do a if in multi-line and if not in multi-line check. Which in this case is global to the first GLSL file, but I'm going to need to do my own tracker. Finds the first thing that's not a white space, and then looks to see whether it's a comment or a multi-line comment. And if it's not, then we have the start of an option name. We find the first white space or slash after that, because it's possible for the comment name or the comments to cut off the line, and it'll be the start of the or the end of the current option name. Cool, I think that's all good. And then the the isPragma option flag that I had from before, from when we first confirmed its Pragma option. That is only used down here to trigger the concatenation insertion logic. So I don't need it. But yeah, everything else in this while loop I can actually copy above and maybe simplify a little bit, given the more narrow scope of the check that I'm doing now. Go to the top, and here we go. Cool. And suddenly this function got quite a bit bigger, but we can handle it. So for starters, do I want to do is this in a while loop? I suppose I do. I've got the multi-line comment tracker already. Cursor is named pause in here, which I don't know, might be mixing up my style a little bit between these. Current block for cursor and replace with pause. And it looks like every mention of the word I want to replace, including there's a subcursor variable which I'm going to rename subpause. Yep. Boom. 47 occurrences replaced. Sometimes the native Visual Studio Editor drives me nuts a little bit, but one of the things that I do quite like is how when you do find and replace, you can just do current block or selected text. When I'm working in Xcode, it's much more tedious to do find and replace in specific sections. Okay, so let's review. So from here we are doing a while, and then if we're not already in the multi-line comment, we need to be looking for comments and for Pragma options. So in this case we say find the first thing that's not a space. This depends on pause being located after the option, so pause plus equals 6. That'll make it to the character immediately after option. Which I now that I'm saying that, I do need to enforce white space after option. So how would I do that? I guess I would just do if line at option or line at pause equals space or tab or character term. Then it is a space. But actually, I need to do the opposite. I need to do if it's not equal. Oops. And these need to be ands, not ors. There we go. Oh, that's all right. That looks more right, but also still kind of wrong. Typing too fast. All right, there we go. So space, tab, or new line. If it's not if Pragma option is not followed by white space, then it's an invalid line, because otherwise, like, you might have something like that, and like that should be considered a token. That's invalid. I'm heading to bed now. Have a great day. I'll keep an eye on your progress the next days. Oh, thank you very much. Yeah, thanks for popping in. Thanks for the raid, and get some rest. If you're still up at midnight, yeah. Don't lose sleep over whatever you're working on, even if you're really, really excited about it. um, but yeah, take care. Hope to see you in here next time. Where was I? Yeah. So if it's not followed by a white space, then I need to abort this line. So that means I just need to skip this. Oh, then I'm being stupid. I had the solution in front of me and I just didn't think of what it was. So if it's if it is followed by white space, then we do the while loop check. That should have been apparent. It just wasn't seeing it for some reason. There we go. And now we are only proceeding if there's a token following pragma option. Good. All right. So now we have moved past. Yeah. So you find the first thing that's not a white space. This may as well be plus equals 7. Yeah, plus equals 7. And then I'm realizing that I have to do an additional check here. Technically, this can lead to a access violation, because what if option is the last character on the line, like the n is the last character on the line, and we check the character after it? I need to actually do the check that says if pause is less than or equal to, or no, less than the string dot length, and the string is now this guy. Length. Then we do the next check. Yeah, now it's pause minus 1. Because I moved position to be the character after the character after option. So now this is now we're not checking the space again when we do the find first not of. Okay, there we go. Find first not of position. If it is just white space, then I think we can just go on and not do anything else, because it'll leave this block, and then it's equal to end pause, so it'll just break the while loop. That's good. This should actually be located in here, I'm now realizing. Yeah, because we don't know if this is a valid, if this actually is a valid pragma option until this point, technically. Okay, and then if it's not equal to end pause, then we check if it starts with a slash. If it doesn't, then it might be an option name. Probably is an option name. But if it starts with a slash, we do if line dot length is greater than pause plus 1, so we're checking the character afterwards. If it's a second slash, then we know that it's an end of line comment, and we would break. In this case, I don't need to set to end pause. The reason why I did that in the original GLSL parser was because there was an outer while loop I needed to also break. But in this case, I've just got the one. Right? Because if we break out, so if we break that while loop, then the next while loop is the one that takes us to the next line in the file. So yeah, that's good. If it's a multi-line comment, we set multi-line to true, and then we look for the star in the next loop. And then we move the position after the slash and the star. Yeah, that looks good. If it's a slash followed by nothing else, then it's an invalid token start because tokens can't begin with a slash. So we just put that warning out and we move on. EP warn, graphics, compile shader source, invalid, variant option name, token begins with a /. And in this case, instead of doing program, we would do header. I would say file, because the file it's not necessarily a specific shader that's dealing with this problem. It is any shader that includes this header. So we will do I think we brought in the hashed include path. Yeah, so we would do hn to string to unhash it. It would be include hashed include path for that, and then line number. Okay, yeah, so we would use line number in here, so I need to uncomment that and the incrementer. And cool. All right. I try my best to keep this stuff underneath 120 characters, but sometimes it gets away from me. All right, cool. So we got proper warning, position equals std min, line find first of white space, or line find // or find line star slash or slash star. I don't know why I did this. I guess it's because I don't know what will follow. I think this is because I am looking for the next token on the line. So the first thing that's a white space, because the white space is the thing that denotes the end of the token, with the exception of a comment breaking up the token that we're in. Because if we're in a token and we detect a slash at the beginning of it, but it's just a slash, and then partway through the same token, somebody does an end-of-line comment or does a multi-line comment, we need to check for that. So actually, this might be the easiest way to do that, to be honest. Just to find first of, find that, or find that, because otherwise I'd be doing another block where I check for the slash and then check for the star or whatever. Yeah, and then when we get to the other side, we are checking for the first non-white space character. Yeah, okay, that makes sense. So on the next loop, then we are either dealing with the comment, or we are dealing with the next token without having to continually search through the token we just left. All right, cool. That adds up. That seems to be good. And so now that we've got the comment handling, we need to take a look at the actual response to finding a option name. So yeah, presently in the main GLSL shader, I don't do alphanumeric checking. Technically, that's just a nice to have because if you have an invalid pragma option name, then what'll happen is that when its variant gets compiled, it will look something like, invalid. Your invalid token name would be put in a define like this, and then the OpenGL implementation will itself give you a compiler warning telling you that you messed up. So yeah, you know what? I don't think I need that. Well, maybe I do. Because how easy would it be for the dev to know from the compiler where the problem was? At present, I have, whenever you compile a shader, I just have the engine dumping out the pre-processed file so you can inspect it, like so. And I also have the developer console displaying the error. The developer console is going to get overhauled once I got text rendering working anyway. So I think we're going to hold off on making a decision on doing a alphanumeric name check until I've got my new error reporting scheme figured out. So I'll go ahead and skip that. So we're assuming a valid token start. So we would do subpos equals line dot find first of space tab or return or a slash. And we're doing subpos because once we find the end of the token, we need to be able to chop out the token from first to end and store it in the buffer. So cool. If it's a slash, okay, yeah. So first thing we're doing is we're checking if it was a slash that we found that terminated the token. We do a check for the character after. If it's a slash, it's an end of line. If it's a star, it's a multi-line, but still a valid token. And for anything else following the slash is inside of the token, and we know it's an invalid one. So that same check from above, this error would go into this block. Yeah. Right? Yeah. Looks like it's literally the same. Cool. And then I'll deal with this in a minute. I just want to make sure that the overall blocking looks correct. If the token is terminated by a white space, that's what's handled down here. Then we move this to the next position to work on. Yeah. Um, and appropriately, we are doing pos equals subpos plus the number of characters it takes to get one past the character past the end. So that is, um, we are not starting our search on the character exactly after. We are starting the search on the character following the white space on the next line. Cool, cool, cool. Valid token interpreted by the line. Yeah. Okay. So in this case, this is the else of whether the supposition is equal to std string view npos. If it so it's a valid token. It's just that it's the last thing on the line. And here we set pos equal to string view npos, which I suspect was to get out of a nested while loop in the original, because I can actually just do the same thing with break. So do I need to do, I still only have the one while loop to care about, I'm pretty sure. Yeah, while position is not equal to std string view and pause. If we're not in a multi-line comment. Yeah, so this was just to break the while loop, it looks like, so I can take that out. Okay, cool. And then the multi-line comment stuff, basically we just search for a star, because that's the only thing that can legitimately start the sequence that will break the multi-line comment. If we find it, then we do this multi-line comment equals false and pause plus. Cool. Great. Okay, so then that just leaves this stuff, I think. And what was in this else block that I left open? If line.compare pos 7 pragma is equal to 0. So this is the check of whether the first thing on the line is pragma. If it's not the first thing on the line, then we need to parse for multi-line comments. Because we need to catch multi-line comments like that, even if it's not a line we care about. Okay, cool. I think we're off to a great start. I'll deal with this section. We're going to take a quick break. I just need to get a little bit of water. Actually, I think I'll brew some tea. Wet my whistle, as it were. And when I get back, I will continue working on the what we do with each of the option names when we find pragma option in the include file. Be back in a few, maybe 10 minutes or so. Alrighty, I'm back. Had a little bit of a break. I got some tea steeping here, and I'm ready to get back to work. So where did we leave off? We were in the middle of setting up include files, so that when you do an include GLSL file, you can do pragma option, and therefore not have to, like in your actual shader, you can just include the thing, and then it'll automatically set up the shader to work with the desired system, provided that you follow its rules and use its macros. And in our include file parser, we had gotten to the point. Yeah, we got to the point where we actually need to do something with the pragma options. So in each one of these blocks that currently has red squiggles underneath it, we have encountered a valid, or at the very least, something that we'll treat as a valid, or pretend is a valid token that represents a option name. So like EP batched might be one of them for batched textures. Not that that's actually not the one I'm using anymore, but you know, whatever. Coming back to this, I pasted in code from the main GLSL parser stuff, which will help me keep on track. This is the way that we do it in the main GLSL files. So what we do is we push back pragma string options dot size. String options dot string positions dot size. So I guess this is storing the end of this. So pragma options string positions. That's the position within the buffer. So we have a buffer that's we're going to keep appending option names to associated with this include file. And then that's cars to line start plus position. Yes. So oh, that's right. Okay, now I'm remembering. When I originally did the GLSL parser, I did have a buffer for pragma option. So each option that you would encounter would go into a string buffer, and then you would use that buffer to push in the option name when you go to, define following the pragma option line. So when your pragma option line does the pound define and define your option. But what I actually eventually did was I realized, well, I don't actually need to do that. I just need to get the pointer and the length within the file buffer. So that's what I'm doing here. So positions, this is the index into the overall source buffer for this include file. So that's literally just the position. If you start from the beginning of the include file and count this many characters, you'll get the name of the option. And then the length will need to be sub pos minus pos, right? So then this is the length. So this is essentially the C string that we pass to GL shader source, because we basically just stick another string inside of the array of strings, which just contains the option name. But the only difference is that this is represented, instead of being a pointer, it's represented as an index, and then the index will take the source, the include source string dot data to get the block of characters that's stored within the string, and then we plus this value to get the one we want. but string name indices dot in place back, string positions dot size. Right, so positions dot size, meaning that the index that we're putting in here is the index into these arrays, because after we've in placed back another one, what used to be the size will be the index to these. Cool. So I just need to get these renamed to what their modern or their include file equivalents are, which in this case I just did include pragma option. So copy that guy. Should probably bring my chat back up. Just occurred to me that there we go. I don't have a dual screen going. I have to keep track of which chat on my phone. Yeah, and sometimes I forget, and people say something, and then they never hear from me. Here we go. So here, within this text, I will do Control F. I will search for pragma option and replace it with include pragma opt. Okay. And that looks correct. Yeah, okay. So, yeah, I guess that's that. These values are now available for use in the main GLSL parser. The only thing that I don't think fits in this model is this guy. I had copied it up from the buffers that we needed for the main GLSL parser, but we need this and this and this because when we do the include pragma option name, we need a way to iterate through. But this doesn't actually apply. The insertion points are used to identify where in the array of strings composing a variant, composing one of the versions of the shader that you're compiling, to insert one of these strings. So that's not necessary here. It doesn't apply because we're not inserting it we're not inserting anything into the include file, I don't believe. Technically, we are just going through these strings. Oh, no, we do need it. I just haven't figured out how to do it yet. So down in the main parser where we've got this going, where we go to parse the include file, we are generating all the data we need for this part. When we go to insert the include file, we are terminating the source string leading up to the include, and then and dealing with multi-line stuff, and then inserting the pointer to the include file here, or the include file text. But now with the new way we're handling include files, this block gets replaced with a loop that will in place back not just one string representing the entire file. We'd be placing back a bunch of strings representing the contents of the string, or contents of the include file going from start to finish, but split up whenever we find a pragma option. So I think there's a critical step missing here, and I'm just having a hard time seeing it. Because once we found the option, we're pushing back the option strings. And we have also what's this again? Oops. Where by the pragma line number, then option name is 12R. Got it. So we actually need to populate this still. So the idea is that this include pragma option string name indices, man, that's a mouthful. That is a vector of positions within the buffer. This is the vector containing the list of keys into this one, I think. So when we iterate through all of the strings that we need to include when we include an include file, we are iterating through these two at the same time. They're index aligned. For each pragma option, we will have the insertion point, so the index into these representing a spot where we can insert oh man, I'm having a real hard time keeping this all straight in my head. There's so many moving pieces on this, but it'll be so cool when it's done. Yeah, I completely lost track of what we're doing. Let me take a quick look at the code that handles the construction of the variants, because that might clarify for me exactly how this will be used and what I'm missing. There we go. Every buffer's been filled for the file. We just need to create all the permutations. Yep. And okay, so here's where it's done. For int I equals 0, I is less than number of variants, I++. And we're doing a little bit of modulo math to identify each variant option with this nested for loop. So number of variants, first of all, is calculated by taking pragma option string name indices dot size, looping through, so iterating through this vector and multiplying 1 times every size of that element. So that means for each pragma option line we encounter, we are multiplying the lengths of those vectors together. So if you have a pragma option line like this, followed by a pragma option line like this, you have 2 options here times 3 options here. So that adds up. And getting back to here, so we've got the number of options. So we do this loop for every variant, divide value and variant lookup key. Here we go. And then we do an inner loop for every pragma option statement in the file, which is not the same thing. Man, this is... Ugh. All right. Sometimes you just encounter a problem that's just like too big to fit in your head at once, and figuring out how to compartmentalize the stuff that matters and doesn't. That's a hard skill to learn, and I'm not by any means good at it. All right, so J is the index of the pragma statement, and that is used to get the that's used to index the insertion points. Okay, and then I divided by the div value, modded by the mod value, is the index for this variance option. So this goes from 1 to, you know, n number of variants. The div value and the variant lookup key, or sorry, the div value and the mod value, which mod value is somewhere. Oh, here, equal to pragma option string name indices dot size. That is intended to transform this value into from a sequence of numbers from 0 through n to like loop back on itself depending on how many options there are. So it's like a modulo operator where every line is handled with a different modulo. So coming back to the example that I had put here, this would be option 1, this would be option 2, this would be option 3, 4, 5, or they're listed that way, or the combinations are listed that way. So the mod value allows you to have the indexes wrap back among themselves. So we want 0, 1, 0, 1, 2, 0, 1, and so on and so forth. Some rather complicated math, but I'm going to trust it because it's been working great so far. So ultimately, it is using the insertion points to access the buffer that we're going to be passing to GL jitter source. So actually the array of buffers, and then replace them with pointers and lengths that represent the thing we want to substitute. So the tricky part is I need to like pre-calculate these values, the pragma option string insertion points. I need to pre-calculate this in the include file in such a way that after I have included the file, I can simply append them to this list. So technically what that would mean is that the insertion points in the include file would be calculated as offsets. So they would be, they would represent the index in the index buffer, or in the, the index in the include file, source files buffers. So get the correct buffer to replace within those buffers. But but when they get inserted into the overall file, they'll all be incremented by the number of characters. They'll all be incremented by the all the characters leading up to the include file so far in the file. This is getting really meta really quickly. This is amazingly hard to keep track in my head. I probably am not making any sense saying these things out loud. But I think I've kind of got a wrap on it now. So I need to come up with the insertion points, and that's this. So for starters, just to double check myself, yeah, it's not used anywhere quite yet. If we look for the other pragma option string insertion points, I'm looking at examples for how this is handled in the main source. Yeah, so this is the part that I didn't copy up from the other. So this section has to do with terminating the string that we are currently parsing, so that we can add another string that's not from the source file. So that's done here. If we're in a multi-line comment, we literally just append the close comment, so that way we can insert in the middle and not worry about it. It's a little complicated to explain why that's necessary, but it's kind of a procedural thing. And then we insert the #define string and the insertion point. So the insertion point would be the string that follows define space, and then we just slot that in depending on the variant we've got. So trouble is that I don't need all this code yet. I don't think. Because I want to do all this stuff, the OGL shader source, whatever, outside of the include file parser. I need to do this like you do the include file parsing to prep the stuff that you feed this in the main call. At the same time, though, how do I handle this if I don't have access to the buffer that we're putting it in? So I think I just need to copy this block, this block, so this block, and this block by themselves, and then break away from there. Yeah, so this has to follow the while loop above. I don't have access to the strings that we need to terminate. That's something that's handled back in the main GLSL parser. So in the main GLSL parser, we get to the include line, and then we go off into include file parsing in the helper function, a whole new stack frame. So we can't or shouldn't be terminating that string left over in the other, because that should be handled by the include, or the when we actually go to insert the include file. Let's take a look at where we actually do that. That might clarify for me, how this is actually going to be handled. That's done in case 2, I think. Here we go, case 2. Here we go, pragma option, and here we go. And this is where the include file comes in. So this is where we determine that we need to load the include file. We go to parse it. Then after it's parsed, this is where we insert the insert back into the the main GLSL file. So here we do the termination of the current source string. Here we do, that's not, it should be like that, a little bit more readable. Here's where we do the closing the multi-line comment. This is where we actually do the contents. So this spot is going to need to be replaced with a loop of some kind. So at this point, we literally are just pushing back into the source strings, the buffers that we're passing to GL shader source at the end of all of this. We're just appending the include file here. We now need to append a group of them. And so when we include all of the strings that we have in that buffer already include insertion points. Right. And so the insertion points that we store when we go to load up the file, they're going to be relative to the start of the include, not relative to the start of the main GLSL file. So what we would have to do is we would have to add those insertion points to the number of insertion points that we, oh boy. So we would need to add them to all of the source strings that compose the main GLSL file up until this point. Oh my God. That is a lot. So what we need to do then, I'm going to do a bookmark here, which I think is KK. Yeah, so I can just quickly go back to the bookmark later. Head back up here. One token, white space. And I need to, I think what I'm going to do next is I'm going to take in this section where we actually add the contents of the include file. I'm going to do that now. And then from there, I can trace back how I need to structure the data that goes in. So we got include source buffers, source strings, lengths, accessed by the hash name of the buffer. So in this case, include source buffers, we're not going to use that anymore. We're going to use source strings and source lengths. Basically doing a for loop through the vector that is associated with the hash name or the hashed include path. So yeah, that makes sense. Okay, copy that. Head back down to the bookmark, and here I'll comment, well, I'll duplicate and then comment out the original. And when we go to in place back, we are now doing for, I forget the exact type right now, so I'll just do auto it in include source strings. What type was that? Pair of hash name and vectors of car pointers. Right, a vector of car pointers. Right. So this will be const auto by reference, and we'll do structured binding in the for loop, in the range-based for loop, which is great C++ 17 feature. We'll do the path, which is a hash, and then we do the vector of strings. So I guess it would be strvec would be the easier way to say it. So the str vector is a, yeah, got it. Okay, yeah. So for every one of these, we push back into the source, fragment shader source strings and vertex shader source strings. So we'll do that and that. Okay. And then, oh, except for I I'm not iterating through every path, yeah, I don't need to do structured binding here. I just need the vector itself, which would be underneath include source strings, in include path hash. Yes. Okay, got it. And then this can just be const GL car pointer. Right? Yeah. And then that's going to be, instead of strvec, we will do str, I guess. And then this will be what we in place back now. Yep. Cool. There we go. Now we've got all of the separated strings from the include file inserted, including the insertion points where we would insert the pragma option configuration. And then we'll do the same thing for lengths. We'll do len, and then we're doing these instead. Yeah. Include source lengths. Is that not defined? Oh, I gotta change the type still. Interestingly, these are GLINTs, I believe, because that's just what the API takes, even though it would be more appropriate for it to be an unsigned type. They use the signed type for some reason. So that's out of my hands, but you know, whatever. It's Kronos. And that's that. Now, the next thing we need is to insert insertion points. So the insertion points that are parts of the include file need to be incremented to represent their actual insertion point in the main GLSL file, and then we need to insert them into the insertion points here, which I am having trouble remember how I did that. Pragma option string insertion points. So normally that's done by prior to inserting the empty string or the invalid string, we insert the index that they would take from the source and length buffers. Which means that we would actually do literally the same code from here. I don't use bookmarks very often. Next bookmark is Control-K, Control-N. Really? Oh, did I delete the bookmark on accident? Yeah, I did. That's fine. So the way that this works is that we insert the insertion point for every string that we deal with here. So I would do that here. And I think that would be all it takes, right? Because now what we're doing is no, that's wrong. That's very wrong. I was thinking that prior to inserting the strings from the include file into the main source file, we would have an insertion point added, but we don't want that for every string. We only want that for the strings that contain an option statement. So that's not handled here. That we do need to append it to this. So at this point, the insertion point needs to point to the offset from the start of the include file to the insertion point, plus the number of insertions that have already occurred. So this actually needs to go first. Yeah. Because I can't use the length of OGL vertex shader source strings and lengths. I can't use those sizes after I've already inserted a bunch of stuff into it. So it would be for a for loop. Yeah, so we would do a for loop through a list of offsets from the include file. And that would be include pragma opt string insertion points, this guy. So forget the type that goes in. GLint, right? These are GLints. So for just GLint insertion point. For every one of those, we would place back into place back into the overall file's insertion points, plus the size of one of these buffers. And they're index aligned, so their sizes are identical up until this point. Yeah, I think that's it. All right, so once we have all the insertion points into these string buffers figured out in the insertion file, we then insert them into the main file, giving them the appropriate distance from the buffers that we already have. Okay. God, this is so complicated. But it'll be real nice when it's done. It'll make the rendering system writing so much easier for the dev and for me. All right, so back to where we were. We've got the tokens being inserted correctly. Now, after we've gotten all of the tokens out of a line inserted, so after this while loop, we now need to insert the pound define line, and we need to insert the null pointer at first, because I'm gonna need to copy this, I think. Or maybe I don't, I'm not sure. When I go to assemble this in the main file, what I do is I pass a pointer to this, to pound define with a space. I think these don't quite align anymore. Yeah, there we go. From pound define to the space. And then on the next string, I will substitute the index that we have stored before for the option name. I suppose I don't have to do this manually. Oh, hi, Jason Odenberg. How you doing? Because I'm losing hair rapidly working on this problem. Yeah, technically when you do a const string in the C++ compiler, it will automatically handle putting that in read-only memory. I technically don't have to manually put them all into the same buffer. I just did in this case because I was overlapping sections of these constants. You know what they say, 10 follicles per 1 IQ gained. I'm doing great in yourself. Yeah. I hope so, at least. I hope I'm getting IQs from this. Yeah, this is a big old project. I'm working on a game engine, as the description says. The thing I'm working on right now is a nicer way to deal with. See if this will even compile. Oh, it won't. What did I forget? Error list, initializing, constant car. What did I do? Did I do something wrong? Yeah, apparently I did. Yeah, I'm basically just making it a nicer way to do GLSL code, because GLSL does not feature include files. It does not feature variant compilation. So I've already got include files working, but I want variant compilation to work inside of an include file. So it's like, yeah, I've got a big long GLSL parser, and then I'm making a parser that nests within that parser, and it's kind of insane. But it'll make it a lot easier to write shaders in the future. So that's the idea. Yeah, like this is a just a simple as dirt shader, intended to be like a material shader, where basically you just include the batch textures header, and then it gives you these macros to use to declare your texture, your sampler 2Ds, and your texture function, and it'll automatically make a version of the shader that works with batch rendering and one that doesn't. So if you're doing an object by itself, like a really complicated mesh, for example, where you don't want to batch it, it'll render on that. If you're batching it together with you're batching a whole bunch of sprites together, then it'll automatically set up the uniform sampler 2D array and automatically slot in the textures where it needs. So it's going to make things a lot nicer, but I am starting to fall asleep. So yeah, I guess what I'll do is instead of doing like I do in the main parser, instead of doing like a thing like this where I have constant expression pointers to this guy, I think what I'll do is I'll just do in quotes define, and then have it be just refer to that literal when it gets translated into read-only memory. Okay, so we've made it out. I do need to have a tracker bool to track whether this is successfully found pragma option, which is a thing I did in the original parser, but I deleted it when I copied the code over, and I'm realizing now that's a mistake. Bool is pragma option. And then it would set to true as soon as we found option. Okay. I just gotta find the spot in this parser where it did do that. Here, this is where I did it. But I need to do, yeah, okay. So at this point, we know it's a pragma option statement, but we need to set pragma option equals to true when we have at least one option. Right? I don't know if I care about that. How's it going? Didn't see you step into the chat there. How's your night going? I think I'm starting to hit the wall. I may cut off this stream a little bit early, just because I'm not thinking straight, and I'm starting to stare at my computer screen a lot. What's up? What's up? I wasted it so far being lazy and watching videos, consuming content. Yeah, I feel you. Easy to get sucked into that black hole that is the internet. Should have started watching earlier. Yeah, I mean, I don't know if I'm even making any sense when I talk about this stuff out loud. This is basically I've got for the purpose of making shaders easier. I'm right now setting up my include system where when you do include a GLSL file, that worked fine, but it didn't allow me to do pragma option within an include. So if I did pragma option within a header that made these options, made a variant of all shaders that include that header, that wouldn't work because previously I was just straight up copying and pasting this and sending the whole thing to the OpenGL driver. What I'm in the middle of doing, and I'm so close to being done with it too. It's so frustrating. I am making it so that when you include a header containing this line, my engine will compile a variant of the shader depending on which options you have in this line, and that you don't have to like do pragma option. You don't have to do like pragma option and the batch textures or whatever. You don't have to do that extra work when you're including a header. And you really wanted to see a parser. Were you working on a parser? Parsers are just the friggin' bane of my existence. Working on a compiler a while back. What was it that your compiler compiled? What language were you compiling? Yeah, compilers are, they're great to have, but they're just so freaking hard to put together. And I just wouldn't be able to trust a compiler, copying and pasting compiler code and trying to make it work if it wasn't written for my use case. Yeah, that's okay. I'm pretty tolerant of bad spelling. I frequently spell badly myself. So what my objective here is I need to populate this guy, include pragma opt string insertion points. This is a list of all of the indexes into these arrays, the C strings, of all the places where we can substitute text when we're making variants. I was compiling while, which is a really shitty language taught at uni. Wanted to write a C11 compliant compiler at some point. Yeah, I've heard of a couple of those kind of more obscure languages. I'm not familiar with while, but yeah. Were you doing a compiler just because that was your assignment for while, not C11? Oh, for fun. Yeah, yeah, I feel you. Yeah, it's a great exercise to do a parser, just like academically, because you get a much better appreciation for what like is possible and not possible in a language, what things are ambiguous and which things are not, and things like that. But yeah, I think anytime I can just get a compiler to do something for me, I would just take that option. I'm not a fan of having to do all this myself. Okay, so at this if statement, we've confirmed that we've got pragma option followed by a space. So this is the point where we know we've got a pragma option statement. We then go looking for options. I don't need to place it. I don't need a bool here. Okay. On the compiler below, I used processor below, I used a Boolean to track whether we had identified pragma option in here, but I'm nesting the while loop inside of a check for pragma option. And if I make it to the end of the while loop without having pushed anything back, then I'll know that we don't have any valid options. So figure that out. Not a real programmer, not nearly masochistic enough. If you don't fetishize pain and difficulty, can you even call yourself a programmer? Yeah, I guess so. I guess not. It's sort of just a personality trait that comes with the territory. But yeah, for this while loop then, I don't actually need to do a check. I can just assume that anything that if include pragma option string lengths, if that has any elements at all for the hash to include path dot count or dot size, right? Dot size. Oh, these need to be wrapped. Okay. I forgot to wrap them. I just copied them from the code below and yeah. These need to be. because I need to have a copy of these on hand, for one for each file. Right, cool. So anyway, if I do pragma option indices add hashed include path. Yeah, that's right. Okay. But anyway, after the while loop, I can just check to see whether we have any elements there, and that should work. But I'm realizing now that I need to actually go in all of these and put in the element access operator. Yeah. Hashed include path. Yeah. Okay. Cool. Sweet. Cool. And now so this is immediately following the pragma option line. So what we need to do is we need to terminate the current line. Actually, we haven't even started tracking the original line. That's something that I whizzed right past, so I need to do that. Where do I do that in the original parser? Oh, the original parser, I do that immediately after getting the shader name. Here we go. So I do OGL vertex shader source strings dot place back, pointing towards the first character after the EP shader line. In my case, I'll be pointing towards the first character of the include file. Yeah, that makes sense. That works. So I'll copy this out as a model, head back up to this guy, and then just do it from the get-go, except for it's going to be this one. At hashed include path dot in place back, and now we are doing the line or the include source buffer instead of the src for hashed include path dot data. I don't need an offset. I'm just going to start the line at the start of the file, and I don't need these offsets either. Okay. So we open up the header file. We immediately push back the C string. I suppose if I'm being most correct, I should be doing GLCar and making that a GL card, but whatever. I don't. Doesn't make a difference really. And then source buffers data. All right, and then when I get to a pragma option line, I will need to terminate this string length by going into include source lengths and appending the, okay, all right, I think I'm getting back into it. So at this point, this is the line after, or this is immediately after the line containing pragma option and all the options in it. So we would say include source lengths dot in place, oh wait, not in place, at hashed include path dot in place back, and we would in place the length of so we do cars to line start plus line dot length. And that will give us that'll put us to the character immediately after option. But I'm realizing right now that that might not be fully correct because there's the end of line character, or the new line character. It looks like that's how I handled the rest as well. I got cars to line start, so from the start of the buffer, that is the file we're parsing, plus the line length, plus 1, because there is already a new line character in the file, and it was removed when we searched for the following line. Yeah, I got it. All right. So line length plus 1. And then we need to do include source strings at the hashed include path dot in place back. I guess I could just do the string literal in here, define with a space, which will go into read-only memory after the game is compiled, and then the pointer to that read-only string will be pushed into the source strings. So that's correct. So we include define. We need to do include. I can start copying code now. We need to do in place back on the lengths to be the length of define, which happens to be 6, 7, 8. 8 for the pound in the space. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. And now we can start include source strings. Okay, and then after this, we push back a null pointer, because this is the insertion point. So when we are inserting the define line, so going back to this pragma option, when we're parsing through this, we get up to this point. We've identified all of the options that we're going to make variants for. We stop the string here, and then we give ourselves a place to insert 2 more strings. The first would be define with a space, and then the second would be the option name. That. And for now, we leave it at null pointer, and we use the main shader. The main shader will, or the main GLSL parser will go in after the fact and substitute this with the name. It'll optionally substitute the define with a space when we're dealing with the underscore character, which indicates that this is an option without any defines being specified. Cool. All right. And then for the second one, this is where we actually get the pragma option insert point. insertion point. Include pragma option string insertion points. There's so many things to keep track of that the names just keep getting longer. Dot in place back, and we're going to place back the size of include strings. There. Yeah. Okay. This is the equivalent code in the other source strings dot in place back, 0 and null pointer. I mean, it did it like this, but whatever, same difference. And then this will be the offset relative to the start of the file, the include file. And then in the code down, I think I did it. I think this is it. Oh my gosh. It's probably some other important thing I'm forgetting about, but I think this is broad strokes correct. Because now that I've got the insertion points all populated here, when this returns, it will come back down here. Yeah, it'll come down to here, and I will then in place back every single one of the insertion points added to the size of GL shader source strings at the time. Yeah, that's cool. That's it. Gotta take off. Yeah, no problem. Yeah, thanks for stopping by. Get some sleep. I think you were telling me before that it's way later over there. Catch you next time. This name is wrong though. So it'd be include pragma option string insertion points for the hashed name for include path hash. Yeah, so we got all the insertion points for this. That's a vector of GLints, yeah, and we take and add it to the, okay. So I guess it's F5 time. Of course, there's still a problem. What is it? Initializing, cannot convert, const car. Oh, okay. So actually it's not liking the way that I did the define string. I thought I could kind of just inline it, but that's not how it works, because that gives you a const car, and I'm pushing back regular cars, not const cars. Where did it go? I was just fucking looking at it. Here. So I didn't like this. I'm presuming it doesn't actually point to my code, but const car 9 to, yeah, and this is 8 plus the null termination character, so yeah, this is the one. So what I'll do instead is I'll do const car pointer define stir. Or you know what? I'm just going to take this, the universal string buffer, out of compile shader source, and I will put it in the global space up here. And then I can Yeah, fuck it, I'll take the rest too. Basically, I had this arrangement below, and I kind of explained this earlier in stream, but I had this arrangement in the shader below where I would insert pointers and lengths from this string whenever I needed to insert certain things. And I made them const expressions. I'll just take this and move it out of the compile shader source because now I have a utility for it outside of that function. Kind of a hacky way. I mean, it feels hacky at least, but it's kind of verbose, but it has the advantage of me being able to identify what pointer I'm pushing into the string buffers before while I'm doing it, so I don't have to go back and think and look up what character 17 and this line is. And then I can just use define stir and define length. These should be static though, so that they're not polluting the global namespace. Because even though this is not an include file, and I won't actually see this in IntelliSense, there's still a non-zero chance in the future that I might accidentally have a name collision with something in the global namespace, and then it'll fail to link. So I just make it my permanent habit to, when I'm just doing a helper function in a C++ file or a helper thing, to do static whenever it's not deliberately going to be shared between files. So yeah, and now I should be able to do define stir and define length in the spot where I did the thing here. So define stir, define length. Yeah. F5 time. What now? Initializing cannot convert from const char to underscore objty. I don't know what this is. Forward types. Because I'm using in place back. In place back, if you're constructing something, what it technically does is it forwards the arguments to the place where it's going to be stored. Did I forget one? Oh yeah, these all need to be pushed back. This can be in place back because I'm doing a return of an R value from the other, but these two need to be. I think this one too, actually, but I'll just use in place back until it yells at me. Yeah, this one too. Did I do it somewhere else? I did it everywhere else. Except for this is code that I copied from the main section, so it should be fine. Name indices, positions, and lengths. Because these are just ints, basically. So those should be fine. Name indices, positions, lengths. sure this one's fine. But let me just quickly check it. No, that wasn't the problem. Cannot convert from const GL car pointer to underscore objty. I guess I'll have to Google that. Underscore objty. So this person had a similar error, and it was also because of in-place-back. So I'm sure there must be a spot where I switched to using in-place-back that I shouldn't have. But I can't think of where that might be. This is just for a vector of size t. So that should be fine. Right? Yeah. Because it just invokes the constructor, the default constructor of the vector, so. And those are fine because they're all ints. Technically, these are fine, I thought. Place back. Place back. But the pointers, I suppose they're surely a problem. Or maybe not. Maybe I only have to do this one. Yeah, so none of these. Stop. So actually none of these have anything to do with the problem. That's interesting. I am pushing back const GL car somewhere. I guess let me take a look at the containers on top of the file that might have something to do with this. So there's the include source strings is a vector or a map of a vector of GL car pointers. So that might be a culprit. It's also possible that I'm calling that I'm providing the wrong type to the wrong variable to one of these containers. Yeah, this is the only one I'm not sure about. I'm going to try push back and see what happens. Yeah, that wasn't it. Oh, it was this guy. It's because I was doing, oops. It's because I was doing const, and it's not const, or the types coming out aren't const, I think. We'll see. Okay, that was what it was. All right, stop. We got an assertion. What do we got? Asserting OGL vertex shader source strings dot size equals lengths dot size. There is a size discrepancy, so I have forgotten to insert something. So version 410 define EP vertex. So there's the include. The next line is wrong. So first, which one's bigger? That's the strings is size 8, the length is size 7. Okay. I'm assuming that line 3 is where the problems start. So we got EP vertex, and then include enterprise.glsl. Yeah, I'll say that's a problem. So the line include GLSL, or enterprise.glsl, so the first include of my file, is associated with a length of 0, which that's definitely wrong. It should be associated with a length of 26. Or 27. So let's review. This is where good assertions really come in handy, because if I hadn't caught the problem there, I would have some other weird behavior that would have been way harder to track down without knowing what the cause was. Assertions are saving my butt again. Okay, so we're pushing back the lengths, positions. So these are the tokens. I think I probably forgot something in the overall parse. So for starters, the very first thing we do is we push include source strings at the hash include path dot in place back. We in place back the pointer to the data. It's occurring to me now that this version of the buffer dot data already returns a car pointer, so I don't need to cast it. So we start here. We then look for the pragma option statement, and upon finding one, we terminate it by placing back the length of everything up into the pragma option line. Then we push back the define. Am I forgetting a new line? No, I'm not. The new line is part of the source. So when we do line length, dot length, line plus 1, that's including the new line character following the end of the line. So we got the define string, which includes the space after the define. We then we then push back the insertion point, which is going to be the string following define is where we do the insertion. We push back the null string. Okay. We didn't reopen the following line. So we need to do include source strings dot and place back. And from here we would do the character after. We would pick up again the character after this line. So actually it would be data plus cars to line start plus line dot length plus 1. So we include source buffers, hashed include path, dot data plus. Yes. Because we're going to be starting parsing on the following line already. And then this will, okay. Hopefully that was it. We'll see in a minute. Okay, another assertion. The same assertion. So, not better. So one is size 7, one is size 8. They should be the same size. So we got include enterprise.glsl. Actually, now that I'm reading that, I'm realizing that that shouldn't be in there. The pointer to include enterprise.glsl, that should be omitted. The include line should not be finding its way into the final file. So I guess it's getting in there with a line length of 0. So I guess that's how we're doing it. The following line, we're only getting 1 character. Oh boy, yeah, this is a mess. At least I have something to fix, as opposed to not having the problem figured out. But yeah, something is not right. Let's step through the parser and make sure everything is a-okay here. Actually, I don't even have to do that. I can just inspect the data that came out. So I got the include pragma opt string lengths and positions. So first thing I'll do is I'll inspect them. They are empty. We didn't do an include file? How did we not do an include file? Oh, because we're compiling EP null shader. We're not compiling my shader yet. We're compiling the magenta shader that triggers when you have a shader problem. So something is going wrong with its include line. So let's open that up, graphics.cpp, and we'll go to graphics init. So during the initialization call for the graphics system, we compile from a raw string, so we're not actually opening up a file. We're compiling this shader source. It's this. Man, how do you do view? Like, I want to zoom in on the text, but not zoom in the whole layout. Is that not possible? I have to do the whole window. Okay, I guess that's what I'll do. So this code, we got EP null shader. It's got a simple include for the basic stuff, which includes the model view projection matrix, the and the EP position. So this just makes a magenta color for every vertex. So it just makes the shaderless object stand out while still maintaining its shape in the shape and location in the same. So it is having an issue parsing. I've copied it out to this other file so I can quickly reference it. But we head back to where we were in shaders.cpp. When parsing it, so I apparently broke something fundamental to include insertions. So we got version 4.10, define EP vertex, include GLSL. So the first problem is that include enterprise.glsl, that line should not be here. So that should be just missing. It seems to be correlated with a line length of 0. So I don't know, maybe that's how I used to do it, but let's take a look at What am I doing when I do control minus? I was trying to change my zoom level when I hit control minus. It's like going up instead of going out. So I don't know what that's about. But yeah, now I understand that the problem is located in the change that I made to the main parser. Case 2 or document case 2. Because enterprise.glsl doesn't include pragma option statements. Here we go. So let me set a breakpoint and step through it. Okay, so at this point we have identified the source file to include, the enterprise.glsl. We are hashing it. We are checking whether there's a buffer file. So that is whether we loaded the file already. We haven't. We go to load the file. We call parse include file. I'm going to presume for the second that that's okay. And take a look at how we integrate it. The first thing we do is we terminate the current string, which means cars to line start minus the distance to the start of this line, which is 24. Okay, so OGL chitter store strings.back. That gives us the pointer to the include line. So what value does that give us? Let me evaluate it real quick before stepping over. Function has no address, possibly due to compiler optimizations. Well, I know it's not that because I'm in debug, so I don't have compiler optimizations enabled. Let me step over the line, see what I got. Okay, so that expression got me a value of 0. So the thing is, though, is that this logic was working before. I'm starting to think that it was wrong, but it was working. So the point of this is to terminate the existing string at the start of the line including the include file. So source.data is the address of the start of the entire GLSL file, the main one, not the include one. we are getting the distance from OGL shader source strings dot back. So the address of it. So the address of include enterprise.glsl. So this value in parentheses is the number of characters to the start of the include line. And we've got cars to line start, which is the number of characters in that you have to go to get to the include, which in this case was 24, which adds up. That's the length of the EP shader, EP null shader line. 24. So I'm willing to bet that this expression equals 0. So what I'm doing is I'm just copying out the numbers and doing it because the watch window doesn't seem to want to do the math for me. So first I've got the pointer value, then source.data, can you get me its address? Let me just do minus source.data. It's not working. Okay, can I inspect it from the autos window? Source, allocator, raw view. That's wrong. Maybe if I just pass it an address of. There we go. Pointer math can sometimes screw with you. Come on, give me the friggin'. It's not gonna let me copy it. I'll just friggin' type the whole thing in. OX1B29EE 46D20. Okay, 24. Thank fuck. All right, so that logic actually seems to work out, the pointer math. I see that there's a distance of 24 between the start of the file and the start of the include line. Oh, okay, I know what's wrong. There is actually a problem with that logic. Where are we? Call stack. Here we go. Cars to line start is unnecessary in this call. I was thinking that if we're going to terminate immediately before the pound include symbol, it's not necessarily at the start of the line. There might be white space, for example, or a multi-line comment. So like you might have prior to your include, you might have something like that, and that's technically okay. So we don't use cars to line start anymore. We just use the distance to the gender source strings, the pointer to the include that we push back. Right? I feel like I've got this incredibly wrong, but I won't know until later. Let me think about this just a little bit more. So the way that I had it before, I did cars to line start, which is every character up to the start of this line. Oh, okay. So actually, I do need the cars to line start. What this was dealing with was the fact that in other situations, the include is not necessarily at the start of the file. In this case, they conspired to be the same number because we only count the code on the line immediately following EP shader, where we specify the shader name. But in truth, that number could be non-zero. So we use the start of the line. So if I started with a file like this, that would include 7 characters. So 7 minus to say 7 minus anything suggests that we are so the back value of OGL vertex shader source strings, that's the preceding chunk up to this point. So when we're reading in the source file chunk by chunk, that would include this chunk, the chunk prior to this include line. So we're getting the number of characters up until that point. And then we're taking the cars to the line start. I think that would always conspire to be 0. Let me just stop this for a second. Go back into graphics and knit. I'm going to insert some stuff ahead of the include file so that it's not starting at position 0. And then I'm going to inspect how that works. Okay, so here we got cars to line start is now 36 and not 24. OGL vertex shader source strings. The back one includes the characters on the top. So this includes the lines I just inserted prior to the include line. Okay, so I think I've re-pieced together the logic here, but it is wrong. It was written wrong to begin with. I don't think it was causing any problems in this case, but what this is doing is it's asserting that pound include, that the whole line needs to go when you've done pound include. That's actually not quite correct. If we go back to the example, if you had a multi-line comment going and then for some reason you did that, you closed it before include, we can't discard this, because if we did, then the whole rest of the file would still be considered in comment. So what, let me go ahead and make the changes that I had in the main file. So what this is doing is it's taking the cars to line start. It is calculating the length of the section up until the line that has a pound include on it, which is fine if pound include is the only thing on the line and you don't have comments, but it is wrong and it doesn't have to be wrong. So we're going to take the moment to fix it. Cars to line start, instead of doing cars to line start by itself, we need to do up until the pound sign. And going back up the parser, I need to confirm whether we have kept that anywhere. So we did not. So what happened was that after we encountered the line, we simply took the first cursor and moved it to the left bracket or the left quote, depending on the style of include. And we no longer retain the position of pound include itself. So I need to do that. So before we set the cursor to anything else, I'm going to do a local variable. So that'll be size t cars to include, or to include directive, I guess, to make it a little more explicit. And that's going to be equal to cursor plus lines to cars to line start. So this, why is it tabbing back like that? I wonder why. It's a couple of times now it's automatically put this back one level in the, I'll worry about that in a minute. But now that I have calculated that, I can now insert it into the length value when we go to cutoff down here. So the source strength length cars to line start minus okay. So first we're going to start with cars to the include directive. So every character in the file up until the include directive, and then we need to subtract the subtract all the characters before the chunk that we've already started. We do that by getting the pointer to the pointer to the first character in the current chunk that we're working on minus the source data. So this is more correct, but it probably won't fix our problem. It's just the problem that I happen to catch in the nick of time. Let's see what happens. Okay, we're still triggering that assertion. So we're going to need to head back through the code again. Step through this one at a time. Okay, so we've terminated the string. Currently we've got 1, 2, 3, 4, 4 string lengths, 4 strings, so that's good. That fourth string there now should include all the comments up until the include. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 characters to keep. And we do correctly see the length of characters to keep on that line is 12. So that's better. It was not working before. We're skipping over the multi-line comment because we don't have an open multi-line comment. And then we do insertion of the insertion points. So the insertion points are not actually dealing with the buffer directly. They are dealing with things to insert, or the pragma option statements in the include. And this GLSL file that we're working through right now, it does not have a pragma option statement in it, so we just skip it, and that's fine. Here, though, we need to include the contents of the file. Okay, and this looks correct to me. Wait, does it look correct to me? Yeah, it does. Because we've only got the one string, and it's the entire source file. Enterprise and GLSL, this is the universal header for blah, 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 blah. So this is actually loading in correctly. And then there's the problem. There's no terminating length. Okay, all right. I know what the problem is, and I feel foolish for overlooking it. The problem is that when we finish this callback, so we start by opening the first string that we are tracking. When we go through this whole loop, we are parsing the whole file for other breaks, but we never terminate after that. We need to do that now. So that would be include source lengths dot in place back, and gotta figure out what the length of the last chunk was. How do I do it in the regular parser? This is all introspection stuff. So what we do is we terminate it by pushing a -1 into the current shader source strings, because GL shader source expects -1 to indicate that it's a null terminated string, which it is. Yeah, so we push a -1. Okay, and hopefully that will just fix everything. Let's give it a shot. I still have my breakpoint set. Okay, we've got a problem. What does the console say? Vertex shader compilation failure, unrecognized pragma option underscore, syntax error in define. So the variant printed out to the console to show what I'm doing wrong. Okay, so for starters, we've got the enterprise.glsl header. That looks fine. Then we have if-def. Oh, that's actually part of the header, believe it or not. So we've got the EV position as part of EV vertex. This is the comment at the start of batched textures. Okay. So there's a problem with the define. So we get to pragma option. We are correctly inserting define, but we don't get any text after it. And if-def batched textures is part of the file we're including. No, that's the wrong one. And there's also a subtle problem that there should be a line in between as well. So we're missing a new line character. Okay, but we're getting somewhere though. This is progress. So I wonder if GL shader source is getting the null pointer. Yeah, that's not immediately clear. Looking at the looking at this, I'm not seeing anything indicating that there's a special handling for passing a null pointer. So I am actually a little surprised that we don't have an access exception problem, because theoretically, if if we didn't actually update the string following define, then it would be trying to dereference a null pointer, and that's apparently not happened, because this stuff actually made it. Well, actually, that's another thing. This code is not necessarily exactly the same as what got sent to the compiler. It's what I happen to have in my buffers. It's possible that it just terminated, but it still didn't give us a problem with, yeah, so maybe there's, yeah. All right, well, let's take a look at what we've got. Because we're still within the compilation phase, so did we, it doesn't look like we have a GLSL dump yet for the shader, so this is the first variant that we're dealing with. Oh, so if this is the first variant we're dealing with, variant 1, the first variant should be we should not be seeing the define in it. Let me see what the next shader looks like. Okay, so we didn't actually get an error on the second shader. If we go to take a look at the source dump, oh, but I don't see a source dump either. And for that matter, it looks like the null magenta shader is loading. But we didn't get a debug break on the same error this time. So the second shader broke for some other reason. So it apparently broke much earlier on for some reason. It's not compiling a second variant. So we got a couple of problems going on here. Oh, actually, it's skipping the compilation because I'm returning false. And now that I'm looking at it, I'm realizing that that's not what I want to do. So it's returning false with the impression that there was a failure to compile, because that's how my compilation originally worked. But now it's a little less clear than that. It's not binary whether the compilation will work. Because one variant might work, the others, one variant might work, one variant might not. So I need to change this to be return val, and then make a bool at the top of the block, and pass it. And then when I go to the return false in this block, return false in, come on, give me the, that's annoying. Okay, well, let's just search for it then. So when we would return false, we would say return val equals false. And then I need to make sure that when we break out, that we don't continue with logic that doesn't hold up. Okay. That was all of them. And now when I search this block, can I do, that's annoying. Maybe it's because the block is so big, but I usually can select to scope the search within a single function. If I do return val equals false, let's follow the path to make sure that it's not doing something that is broken. So in this case, shader source does not begin with EP shader. Well, actually, in this case, yeah, that's a kind of a deal breaker for all variants. So we'll just do return false. Same thing for not having a program name. But there were multiple examples below where actually, now that I'm thinking about it, it's specifically compilation errors that I don't want to return, not parsing issues. I don't know, let me follow through with this and see where this goes. Okay, so when I do compiling and linking, now I set a return value instead of actually returning, because that way I can still attempt to compile the other variants. However, when we go to do the subsequent compilations, this gets a little tricky because I do want it to go out. So there's nested for loops. The inner one is for every pragma option statement. Oh, I think this is for, yeah, so compiling and linking is only within a single for loop that executes once per variant. So I can use continue. If we go return val equals false to find the three cases, I would use return val equals false, so that way we're returning false, even though we might have successful shader compilation elsewhere. And we would do continue, and that will shoot us to the next variant without attempting to compile the fragment shader, the remaining shader, I should say, or link them. Cool. Okay. Well, let's see if I can get any more information about the problem now that it's actually going to try and compile the remaining things. Okay, so interestingly, the other shaders apparently compiled fine. Or did they? Because I don't see... anything. For every shader that compiled, I should have seen a file pop out here. So the variant, there's only one variant of the magenta default shader. So that looks right. Actually, now that I've done my troubleshooting for that one part, I can get rid of that. But we're not even getting to compiling the remaining shader. We don't have a single... Okay, so there must be some reason why the second shader is not compiling. And I want to see what it is, because I think it'll tell me about the first problem. It'll tell me whether the problem has to do with define or the character after, or the string after. So let's head to the next iteration of the for loop. It only executed once. Yeah, so it must be unaware that there is a variant to compile. So there must be something wrong with how I'm parsing out the options in the include file. Let's make sure that I've not fucked up my example. So this is the material that we're loading, or the material shader that we're loading. There's the include for batch_textures.glsl, and in batch_textures.glsl we have two options, underscore and batched textures. That means we should be having two variants. So the fact that we're not tells me that we fucked up somewhere. First thing I'm going to do, I'm going to go and inspect these buffers. Oh, I know what I missed. I know what it was. I didn't at any point construct a key for looking up the shader variant based on the hashes of the shader options. Okay, so there's actually a whole mechanism that I forgot to implement, and that's this std set hash name. One of these is used for the key for looking up the variant that you're in. But no, actually, no, I don't have to handle that here because that's actually handled when we return. Okay, maybe I didn't. Maybe I didn't mess up this part. Okay, but heading back to the thing I was inspecting before, if we go to include source strings, we've got two files. Sorry, two include files. This one is the batch textures one, so this is the one I care about. So we got four strings. There's the first one. The second one is define. The second one is still null. So it has not been set. And then the following one is a new line and then if def, which is here. So that the following line is correct. So the problem is that we're not setting the null pointer correctly at some point. All right, I'm gonna take a break. I do still think that I can get this done tonight, but I need to rest my brain for just a short little while. Probably be about 10 minutes. All right. So I am back with some tea that I didn't have before, and a little refreshed, which will help. All right. Where were we? So we were tracking down why the pre-processed output of a shader include doesn't have the correct define in there. When we are dealing with the basic case of the underscore, the expectation is that the following line does not have any characters in it. What I think is happening is that the pointer, the C style pointer to the defined string is not being addressed. It's not being changed the way that it would be in the main file, and neither is the null pointer. So I think we're actually sending a null pointer to the compiler, and the compiler is just interpreting it as a null string. So the new line character that we're seeing from this line down actually is the one, where's the, here, in this header. It's actually the one already located between the pragma statement and the ifdef. A new line string would be inserted normally along with the option name. So, because otherwise you would have, you might have this situation where it'll insert and then pick up on the next line. So assuming that that's the case, then that would indicate that there's a problem with how we are inserting or handling inserted pragma statements. So let's take a look down at the main GLSL parser and see how we handle the insertion, the variant insertion code. Okay, so that's going to be here. So on this first one, we are looking at EP null shader, so we'll continue. Now we are looking at test renderer 2D. All right, so it is skipping right past it. Because pragma option name indices doesn't contain anything. So I missed a step when integrating the insert code. Here. So here is the spot where we reintegrate the data describing the insertion points and the options into the string. Or into the multi-string representation of the main GLSL file. We do that by taking for every pragma option insertion point, we insert one into here. So let's review that. I think I had forgotten to do a few things inside of this block. And in fact, it just never gets called. Let's head back to it. I put a breakpoint in the middle of the insertion points handling, so apparently there's not a pragma option insertion point being pulled. Size 0. Yeah, and it doesn't appear to exist. So it doesn't appear to exist in the parser code up above. So let's review when this is used. So none of this code appears to be getting executed. Because if it had been, then the insertion points would have a size by the time we get there to the assembly stage. All right, let's do this again. All right, insertion points. It's not hitting the breakpoint that I thought it would. Oh, that's because we need to continue. Oh, I'm being an idiot. Okay. Yeah, I forgot that I was also that I had to click continue twice in order to inspect the second shader, because this function is compiling the null magenta shader first. But the problem is still that it's skipping the insertion point, so we're still on the right track. Continue. There we go. So this is the parser parsing the header file containing the pragma include. At least I'm very sure. Batch textures.glsl. Yes, this is the one. All right, so where are we in the parser? So we've identified pragma option, and we're looking for option names. So we find the first thing that's not white space. We check if it's a slash. It's not a slash, so it's probably a valid token start. Subposition 16. Position 15 to 16. Oh, right, because it's the underscore, which is just a one character name. It's not a slash, so we treat it as a valid token. We're pushing the indices into the positions and lengths. Which appears to be correct. And we go through for the next token. Oh, god damn it. I accidentally clicked step out, and that put me back in the main parser. Use the keys from now on. Good. Okay, so that's the first one. That's the second one. Now we are looking to see what we can do with that data. So cars to line start is 401. Is that right? 401 character? Yeah. Let me look at the file again. Oh, because I have all this commenting at the top. Yeah, so 401. What? That's actually maybe not correct. I've got 410 characters. 401 is here. Oh, CRLF. Let me change the line ending. Yeah, that's 401. Yeah. When it reads when you read a CRLF line ending into the engine or into any portable C code, it'll strip off the CRLF and replace it with the LF. So that way it's got standard line endings. Yeah, so that's right. So curse to line start plus line.length, which is the entirety of the thing plus the new line. Yeah, that's good. Include source strings. Then place back define string, so we're pushing back to the define string and this length. Then we are pushing back the insertion point. Which also looks right. Then the null pointer. Include buffers. So somehow I think that this data from include progna string insertion points is not finding its way back into the file. So out here in the main GLSL shader parser, we terminate the string that led up to the Pamela include. we do the same for the fragment shaders source, because we've got two shaders that we're parsing at this point, technically. Insert the insertion points. So it's at this point that we are about to insert into pragma option string insertion points, which if we take a look back down at the assembly stage, it's not even used until after we use pragma option string name indices. I don't think I'm setting up pragma option string name indices correctly. Yeah, that's the problem. Watson, I think I've cracked it. So, I am correctly using this value. I am not using this one at all. So, option string name indices is the index into here that lets us iterate through So I need to push include pragma op string name indices into the main GLSL one and make them relative to the end of the. Okay, I think I've figured it out. It's kind of hard to explain. Okay, so I'm stopping debugging. Heading back to the place where we integrate the include file down here. I need an additional for loop. For const, I don't remember what the type is, include pragma op string name indices for include path hash. And then what does it contain again? It's a std vector, right? Of what now? Size t. I think. a vector of a vector, ordered by pragma line number, and then option name is 1, 2R. Okay, so for pragma line, and then I need to do a nested for loop for const std vector size t by reference per pragma option in include, or in per pragma line. Oh, actually, it's just const size t. So this is every single option in the buffer. Now I got to go into pragma option string name indices and fill it. And that is similarly ordered. I'm just not quite following what exactly this is used for. So so I get that whenever we encounter a new option, we will emplace it in the back. Oh, okay, I get it. So when we actually go to assemble the final shader source that we send to the compiler, we are iterating through every pragma option line, and then through every option. So I need to push back each row in the includes version of this vector. And then do I need to change the indices themselves? I guess it depends on how they're used. Down at the parsing stage. Here. We are accessing the pragma option string positions and string lengths to get the strings out of the source data. Okay, so freaking great. That means that I've got to change this code too. Because currently the way that it stitches it together, it will loop through it'll loop through all of the lines that we have pragma options for, and all of the options. And when it gets to the point where it's going to insert the correct string, it is using the position data to directly access the main GLSL text, no matter what. And I also need it to reference the include text in order to assemble correctly. Which tells me we need a new container. So I need to actually not only store all the stuff that I'm already storing when I'm parsing, I also need to track which file buffer to read data from. So how would I do that? I could do another map. That's not a problem here because we're going to be inserting from space string and space length always. So we're just inserting a space in that case. But here and actually in this entire block, we are referencing source. So I need to have an index aligned container associating these string name indices with the buffer that we were reading from. Oh boy. Okay. So this would be an std vector of type GL car pointer. This would be pragma option string name buffer source, I guess. Sources. And then when I use pragma option string name indices, I will also use the sources to track which source it came from. I'm using a const car pointer because I basically would just take the address of the first character in the buffer and then we can use it directly. So in this case it would be source.data. Same here. Yes. So there's parity with back dot and place back, so that there's parity with each value in name indices. and then I'll have to use do the same thing in the include parser, substituting the pointer to the first value there. Cool. All right. So this is about to get way wordier than it already was. I need pragma option, string name, buffer sources. At these same values. Dot, or no, that's it. Oh my god, this is such a nightmare. All right. Right, let me rewind that a little bit. So instead of using source, I use pragma option. Sorry, pragma option string name. Come on. String name buffer sources at the same accessor that we use for the name indices. So that's actually here. So this would be at J. Oh, so that's actually maybe easier to read then. Right, because we're using yeah, we're using them here, 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 and here. But then I also need this sub value. So it's going to be at J at I divided by div value mod value. Oh boy. I really hope I don't have to come and work on this code ever again in the future. So this should work. Yes, it does. So I'm okay. What I'm going to do instead of just inserting it into all those is I'm going to say GL car pointer source buff and set it equal to the pointer that I get from that. So I'll replace source with source buff. And then I don't have to use data or cast here. Yeah. Okay. So that solves the problem of making sure that it's actually reading from the correct source. So it can either read text in from the main GLSL file or the header. Man, this turned to be such a huge project. I'll be so happy when it's done. Okay, now that I've done that, I need to actually get the correct options in. So pragma option, string name indices. Actually, this code might be way simpler now, because now I can just do for every vector in excuse me, for every vector in per pragma line, or sorry, for every vector in include pragma string name indices, I can just take and push its rows, so its lines, into this guy, or pragma line. Because now that I've got the buffers switched over when I'm parsing from the include file, I have now got the ability to line. Yeah, so now these offsets, I don't have to make them, I don't have to like add the insertion point or whatever like that. I can just use these directly because it's going to be an offset from the start of the include file. String name buffer sources dot pushback, right? Trouble is though that I have to push one in for. I have to push in the pointer to this buffer for every sub element in here. So now I'm going to do a nested for loop. For const size t in or per pragma option in pragma option string name indices dot back. Now we can push I need to push the buffer, the pointer to the insertion. God, I'm fucking tired. I need to get the pointer to the buffer that holds the source file for the include, and push that back into Actually, I don't need to access the element there. I can just do unassigned int equals 0, I is less than, do an I. There's not an I in this outer scope, is there? No, good. I is less than per pragma line dot size I plus plus. Then do pragma option string name indices dot back dot push back or in place back. Yes. There'd be a line. Wait, no, that's not line. But that would be index source buffer, or no, include source buffers for include path hash dot data. Right. So for every name index in here, that is the index into the source that represents a progma name, we now have an association with the data at the data pointer to the start of whichever file we are parsing through. And actually, now that I'm thinking this through, this could actually be even simpler, because all of the fingers of this tree will always be the same. So actually I can do one level above and do or not indices, wow. And buffer sources. Yeah, so what I had written was actually going to be wrong anyway. But what I can do is I can do this guy and just directly do push back or in place back. Directly do the value and then directly use it later on. This requires that I come back up to this guy, take out the nested vector, and then come back to where I was working. Yeah, and then I need to fix this because I no longer need to push data into the fingers because it's always the same. Okay. And now for each location where I did in place back, copy, copy, paste. I would then, oops, nice, 3. Oh, this is the only place where I do that. Okay, so instead of in placing back just an empty vector, I am going to be in placing back source dot data. Cool. And then down here, where I was taking the source buffer and doing this secondary access thing, that secondary access doesn't matter anymore, only the first. And I'm saying access like you access a thing, not access like a scalar on a, yeah. Okay, I think that resolves everything I was worried about, so. F5 time. All right, fuck it. What did I miss? Cannot convert from T. Oh, I used in place somewhere I shouldn't have. And I need to do a cast. Because this is coming in as a const car pointer, which is not correct. All right. Show me the money. And I still got my breakpoints. All right, what did we do? What did I do? Vector subscript out of range. So something's going on with my pointer stuff, my pointer math down here. So the source buffer is pointing towards the entirety of the main file again, which is good. Pragma option string name buffer sources. Is pointing towards batch textures.glsl's source, so that seems that seems right. So the problem must be in here somewhere. Source buff correctly pointing towards the other. Pragma option string positions is empty. So we haven't even accessed anything in it yet. Pragma option string name indices has an element in it. It's got 0 and 1. I am accessing the wrong data. Pragma option string positions and string lengths are not being filled. Well, at least correctly. So I'm doing an element access here in an array that doesn't have, well, a vector, I should say, that doesn't have anything in it. This should be filled with the values that we parsed from the include file. Okay. Where is this? Look for option names. So this is the Pragma option section. I need the include section here. Yeah, it's another thing that I forgot to initialize here. I need to actually, yeah, stop the show, stop everything. This needs to be filled with the the data from from include pragma op string positions as well. So is there anything else that I'm forgetting to set? Include pragma op string name insertion positions. Okay, that's being set. Insertion points, lengths being set. I don't see it being set, so lengths and positions are not being transferred. Include pragma insertion points, lengths, and positions, name indices is being set up. Good. Oops. Include source pragma opt strings is never used. Which is interesting. Might mean that I've missed something. But now I'm thinking that I didn't, because I don't see the equivalent pragma option. Positions, lengths, indices, buffer sources, insertion points. Yeah, so I'm going to comment that out and hopefully I don't need it. Okay, so that just leaves these two things I need to initialize. So I don't actually need to modify these values, I can just dump them straight in. So would it be possible for me to just do pragma option string positions dot append or something? Or maybe a pushback that takes the because I really just need to stick the one end of the vector, the one vector onto the end of the other. Doesn't look like it works that way, but I'm just going to do a quick search on the internet in case somebody has done this before. Want to make sure that I don't, like if I don't have to write an extra for loop there, then I don't want to. Okay, yeah, so they do an insertion using iterators. That's way more elegant. Pragma option string positions dot end, and then we're gonna do it from dot begin, and then dot end, and cool. And we can do the same thing for this one. Okay. I can't do the same thing here because every value I need to add INS point. Though, now that I'm thinking about it, I could do an insertion store the iterator to the new elements, and then go through and do the math upon the value. So what that would look like would be like I take and insert all of the elements from this at once, and then go through all of them and add OGL shader source strings.size to it. The purpose there being that I'm guaranteeing that I'm only getting one allocation. So like if I fill in a whole bunch of insertion points, I'm not going to cause the vector to, resize and then resize and then resize. Small optimization, but it'll make the code more readable, and it's better code anyway, so let's do it. So this would look like pragma option string insertion points dot insert, and then we would do include pragma opt string insertion points dot begin, and then dot end, and actually I need to get the end iterator on this one. And then I would need to iterate through the last several of these in here. So I would go for unsigned int I equals 0, I is less than dot size, I plus plus, and I would do pragma option. Yeah, I don't want to do a iterator or reverse iterator on this pragma option string insertion points because it's possible for it to have more elements than this. And if I was to get an iterator to the back element before I did the insertion, then it would be invalidated by the insertion operation. So what I'm going to do here is I'm just going to take the back element and then go back and back and back. Yeah, which is maybe a weird way to do it, but pragma option string insertion points dot back. It would be nice to do rbegin and iterate through that, but then no, that would work. I could do that. I could do auto arit equals pragma option string insertion points dot rbegin. And then I can use the reverse iterator to do the access. Though it's technically like that. Equals plus equals this guy. Cool, and then I'm not conditionalizing it on the no, that's exactly what I want. Okay, cool. I'm gonna comment that out just in case I find a problem with this code and I need to go back to it. Now I can do an insertion on this guy. But then I would need to iterate through this one anyway. Which I can do with a regular for loop, actually. So that's probably okay. So what we'll do is we'll do pragma option string name indices dot insert dot end this one dot begin dot end and then for unsigned int I 0 I is less than dot size I plus plus I would push back the value. Boot source buffers, could have bash.data. Right, okay. Good. Um, and I'm just going to do the same thing for this for loop that I don't need to loop through anymore. Like so. And then do the same thing for source lengths. Yeah. Good. And then that's better. Okay. F5 time. So let's see what else I broke. Okay, build error again. What's the hold up? Cannot convert from std pair to obj TUI. Yeah, I'm not seeing where I do that. The only thing where I'd imagine there's a... Oh! Hang on. Reverse iterator. And that's not it. The only new stuff I'm doing here, I mean, I rewrote some of it, but the only new stuff that I'm doing is the string positions and string lengths. But that's not using in place, that's using insert. And when I comment it out, there's still a problem. Well, actually, that's interesting. I comment it out and one of the problems goes away. So let me reread those problems. Cannot convert from std pair, const hash name, std vector, size t allocator hash name to obj ty. Yeah. That's because these are maps and I didn't specify the key, which is include or hashed what is it? Hashed include, come on, autocomplete. Include path hash. All right. Dot begin. Yeah, and man, one of the problems with huge systems like this is that when you have to do a whole lot of work between compilations. It's hard to incrementally build and check yourself sometimes. Okay, so that clears that first error. The second one was cannot convert from std pair to object type. So that would be, let's look for another include. Yeah, I forgot the include path hash here as well. Okay. Okay, well, compile this time. Can't decrement value initialized vector iterator. Oh, I'm not dereferencing the value correctly. What? Okay, so there's a problem here because there's not parity between pragma option string insertion points and include pragma option string insertion points. I was expecting that there would be, because we just called insert. That was right here. So let me break and start over. So this has got nothing in it right now, which is what I'd expect. We want, oh, but this has nothing in it too. Include pragma. Oh, that's because I'm on the first. No, it's not. Interesting. So what's the, just to confirm, shader name. Yeah, so we're still compiling EP null shader here. So this is a shader that, the default magenta shader that kicks in when other shaders don't compile. So this somehow got up to be 1. God damn it. I forgot another. All right, I forgot to put another accessor there. So it's doing the wrong type of iterator. Okay, did any others? Include. Okay, that's all of them. Probably. Almost definitely, okay. Oh my god. Going up on nearly 6 hours. This turned out to be a longer task than I thought it would be. All right, what now? Vector subscript out of range, which if I recall was the last problem we had down here. So J is 0. We are, well, which program are we on? So at this point, we've successfully compiled the default shader, the null shader. Now we are in the shader that we actually want to get working today. Test renderer 2D, autos. We are iterating through every shader variant. In the vertex shader, the last shader, or the last line that we inserted was in vec2 in UV. Which is this line. Which I didn't expect to be the last line that we inserted. Because that's definitively not the end of the file. It's not near the insertion point. Actually, hang on a moment. Oh no, that's totally what I expected, because that's the start of this last final block that we are inserting into the, yeah, so that's fine. The last block for fragment shader source starts with define with a new line character EP vertex. Oh, it's just define. So we are looking at the fragment shader now. So in the fragment shader, so it looks like we've successfully assembled the vertex shader, but looking at the fragment shader, we are in the middle of assembling, what's the line? Define. So we're in the fragment shader. We are in the middle of assembling the variant. So we made it past BTX sampler 2D text. So this block is done. Yeah, I don't get it. We're missing something here, I think. Because cutting out vertex and the vertex section and those tags, we should have one string 1, 2, 3, 4 string, so 5, 6 strings. We have 9 though. I must have been forgetting something. EP vertex, EP fragment. So it looks as if we are it kind of looks like the define line is inserted at the wrong point, because the define line should be inserted at the same point that it was on the vertex shader. Which is to say on line 6. So we're inserting shit in the wrong order. So I'm going to need to step through this logic again. And before I do that, let me take a quick peek at how EP null shader turned out. Yeah, so in the trivial case with including a file that does not include which does not include a pragma option statement, it seems to be working fine. But let's start this over. Which one am I on now? Yeah, we're on EP null shader, so continue. Now we're on test renderer 2D. So at this point we have included enterprise.glsl. I need to hit continue once more, and then now we are including batch textures.glsl. All right, so at this point we've already pre-processed the, or already parsed the batch textures shader header. So this should be full of the things we need. OGL, okay, fragment shader source strings, size 7. Version whatever, tag at the start. We got define, and we got EP vertex, include, sorry. Okay, the include line is emptied. Then we got the commented out enterprise GLSL, the contents of the enterprise.glsl. Which I'm a little confused by the ordering. Oh, that's just a new line character. Okay. And then we have the include line. So everything seems to be okay up until this point. Okay. And now the lengths should 7, 7, 6, 6. So good. So we've successfully closed out the string. Yeah, man. So we've properly picked the correct insertion point. It's set to 9 for the insertion. And I say that's correct because if I take a look at the OGL source, strings, wait, that's not correct. So I think we're most of the way there, but there's still a couple of oversights in the parser that I'm having trouble getting to the bottom of. I'm still going to need to keep working on this, but I'm going to have to do it at a later time because now we just hit 6 hours on the stream. I got a couple things I needed to get done tonight. So I'm going to go ahead and call it. Thanks for the folks who popped in, especially for that raid earlier. I think what I'll do is I'll finish this offline because this is some really boring work, and then come back on the stream when I'm ready to do text rendering. All right, have a good night, everybody.